All right. Hello, hello, hello. Hope everyone is doing well. Hi, Penguin Operator. Hi, System Chat Guy. Hello, welcome to the stream, as usual. Um, so I'm trying to fix my shirt. It has, but yeah, Andrew. Hello, welcome. Hope everyone is doing well. Um, welcome to this new day. So yeah, sorry yesterday there was a lot, like this room was a furnace yesterday. And I had to get, like, I almost like puked out of how bad it was, and was feeling sick afterwards, so I couldn't really continue the stream. Sorry for that, but here we are, starting again. It is definitely better today, way better today. um, so yeah, that's that. Um, Give me a second. My shirt is still not. There you go. Perfect. Oh, all right. So one of the things that, well, the thing we've been doing is separating the stream in reading The Joy of Cryptography and then reading, sort of learning Rust. Today it's gonna be our last chapter of The Joy of Cryptography. And so, which is very cool. It's going to be chapter 16, dedicated to signatures, if I remember correctly. And yeah, so it's going to be entertaining. Hopefully, we'll be able to see sort of all of the, you know, all of the things that are necessary to understand the, ooh, sorry, the Bitcoin white paper. So after we finish this, we're going to go back to the Bitcoin white paper, which is the one with which we started all of this, all of this stuff, right? Because we saw, like, for a split second, we saw digital signature being set in the Bitcoin white paper, and then we decided to go read Joy of Cryptography because Andrew told us about its existence and it seemed pretty cool. So yeah, that's it. um, what were you doing last week? So last week, the thing is, I spent like 2 weeks without streaming. So sorry guys, but the week before last week, I was focused on my intern project, finishing my internship and all of that, and then moving out of San Francisco. I'm back in college, so yeah. And then last week I was just resting. I was resting because, like, after the internship and everything, I don't know. I had arrived here, and so I just met with friends, met with my girlfriend, everybody, relaxed, and now I'm back because, like, I don't know. It feels weird to not be doing like something, especially when I want to continue this blockchain project because I want to start coding already. Like, there is a part where I feel this is, like, everything is very interesting, but I also want to start coding to, like, the actual thing. And so that's another motivation that keeps me up. And it's like, all right, we gotta turn on stream today. So yeah, that's all. That's all. Um, so today we're going to our last chapter that we're gonna take a look at. Fabio, yo, yes man, code the blockchain and use your memory allocator for it. Yo, let's go. But yeah, I'm not sure if I would want to use the memory allocator because, like, who knows? Maybe it's completely insecure. Um, which it kind of is. If you generate, like, if you have a buffer overflow of any sort, it, like, overrides the block and, like, it just messes everything up. But yeah, we technically could. In the age of AI, don't worry about security. This is true. Best advice. Best advice. But just, yeah. All right. All right. Let's transition to the coding scene. Here we go. And let's take a look at digital signatures. But first, actually, never mind. I need to I need to change the profile to the Twitch one. There you go. Perfect. Thank you, Hypermonconfig. And then we're going to set it up here on my monitor. Input. Oh no, settings, input, aspect ratio, original. Perfect. Alright, great. If they make it secure, why can't you? Sure. Are you wearing socks? Program in rainbow socks? You're an arch like me. Yeah. I am not wearing program in rainbow socks. I am wearing just, you know, dark socks. Just these are the socks I use every day. But yeah, I'm using Arch. Transitioned to Arch a while ago, and no longer the macOS some of you guys are used to. So yeah, it's a little bit of a love-hate relationship, but here we are. All right. Remember the usual procedure. Feel free to tune in and out of the stream. This is basically just going to be an audiobook because I'm gonna be, I'm gonna be reading, and that's all, right? If you want to sort of keep up with the reading, you can definitely do that. But this is just gonna be a while, around an hour of us just reading. Sorry, I am an Ooga Ubuntu Booga. That's completely okay. That's fine. I feel like any flavor of Linux is great. But yeah. Alright. Public key cryptography, digital signatures, chapter 16. In chapter 9, we used pseudo-random functions for message authentication. If the correct MAC tag accompanied a message M, this was proof that someone who knows the key has vouched for M. MACs are symmetric key primitives. The same key is used both to generate and verify a tag. So what I understand from MACs, and this just comes from before the joke of cryptography, is you have this function for which you have the key and the plain text, and it serves as a tag that then you can attach to the message to show that you actually know the key. Nonetheless, let's take a look at the need to adhere to the Rust dress codes with socks. True. But yeah, let's see. Imagine you discover a bug in your company's flagship software product. It decrypts ciphertexts received from the network. Oh wait, this is chosen ciphertext attacks. Yeah, we already know about this. We want to go to this section. Chosen ciphertext attacks have shown us that there is risk involved when decrypting a ciphertext that has been crafted by the adversary. Imagine there was some way to certify that a ciphertext was not adversarially generated, but was generated by someone who knows the secret key. Such a certification would give the decryption algorithm a way to distinguish honestly generated ciphertexts from adversarially generated ones, so that it could refuse to decrypt the adversarially generated ones. What we're asking for is not to hide the ciphertext, but to authenticate it, to ensure that it was generated by someone who knows the secret key. Later, we will discuss how to apply this idea to chosen ciphertext attacks. For now, let's develop more clarity about authenticating some data. Authenticating that some data was generated or was chosen by someone who knows the secret key. Let's begin with a simple thought experiment. Okay, let's see. I choose a string S uniformly at random from, strings of length lambda, but keep it secret. Will you be able to guess what it is? I guess no, right? Even if I let you have many guesses, any polynomial in lambda, you will guess correctly only with negligible probability. Then suppose that instead of one string, I have many strings stored in a random dictionary. Okay. Let's call it L. Each L of X is chosen uniformly and independently. So this is basically a random oracle. You can ask me to reveal any value in the dictionary. Just provide its location X and I will tell you L of X. You can also try to guess a value by providing X and you'll guess Y for L of X. Is it possible for you to correctly guess a string that I haven't yet revealed? Again, the answer is no, except with negligible probability. Since all of the strings are chosen independently, seeing all the strings doesn't help you correctly guess this string. This seems like I mean, this is clearly not a zero knowledge proof because you gain knowledge from like whatever guess you make. You know what the L of X for that guess is, but like it seems kind of like that, right? Where you're trying to prove that you know something without revealing that specific fact. No, not. Of course, it's not that concept. It just sounds like kind of similar. If we now replace the random dictionary with a PRF, a pseudo-random function, we will have what is called a message authentication code. For every string x, the PRF output, which is f of k, x, is hard to predict by someone who doesn't know x, even if they are allowed to see the PRF outputs for other strings. Thus, only someone who knows k can generate the pair x and then this guy. So basically what we're doing, I mean, right, it's almost like a hash function that's sort of salted by the key, and then you just say, oh, it would be very difficult to guess what this hash should be if you don't have the original text, right? So, I don't know, we call f of k, x the tag, or mac tag of x. It authenticates x. If you see x accompanied by the correct value, you can conclude that someone who knows k has vouched for x. Be careful, it doesn't mean that the person you're currently talking to knows k. Perhaps that person is replaying a correct pair that they heard from someone else who knows the key. A tag can be verified by recomputing the correct tag using the secret key and comparing it to the given tag. A forgery occurs when an adversary generates a correct tag without having seen it before. The security guarantee of a Mac is that it is hard to generate a forgery, even after seeing many examples of correct tags. We can formalize this Mac property of PRFs as follows. Yeah, this is just a formal definition, right? I do have one thing I want to take a look at. Okay. So what I imagine is this is what you transmit, sort of like, this is your plain text in a sense, right? And then you encrypt it, and that sort of ciphertext is what you send, right? And the other person decrypts it, takes a look at x, computes the pseudo-random function for x, and if it is a chosen ciphertext attack, it's very difficult that they chose the ciphertext that gives you the good x and the good pseudo-random output. And so that's the way you authenticate. Okay, this makes sense, right? So let's take a look. Let's go back. This chapter introduces digital signatures, the asymmetric key equivalent of MACs. A private key is used to produce the authentication tag, and a public key is used to verify. Security definitions for digital signatures. In a digital signature scheme, a user first generates a key pair using a key generation algorithm. Only someone who holds the private key can generate authentication tags, now called signatures of messages. But anyone who holds the public key can verify that the signature is authentic. Okay. Thus, verification must happen differently than for Macs. With a Mac, at least Macs as we have defined them, a tag is verified by simply recomputing the correct tag and comparing it to the given one. We cannot expect digital signatures to be verified in the same way, since the person performing verification cannot compute correct signatures on their own. Thus, a signature scheme must specify an additional explicit verification algorithm. Okay. Interesting, I guess. Okay, so there's one thing that H1's awesome. Let's do a hi, Sir Altman. Welcome back. Yeah. Here we're reading about So I do have one question here, right? When we're talking about digital signatures, which would be, what is the need for digital signatures? You may be saying, Sharif, you're stupid. You clearly just read that. Yes, right. You want to authenticate that the ciphertexts are coming from a trusted source and etc. But like, can't we just run the exact same thing that we were doing with the Macs? Can't we just have X and then the pseudo random output be our plain text and then just send that, right? Because then it would be the exact same principle. No? You decrypt it, you take a look at X, you take a look at the pseudo random output, you just verify that's the case, right? And that's it, right? Here, I mean, they're giving me the explanation, right? So it means I'm not understanding something. With the Mac, a tag is verified by simply recomputing the correct tag and comparing it to the given one. We cannot expect digital signatures to be verified in the same way, since the person performing verification cannot compute correct signatures on their own. And this is my thing. Like, why? Right? Like, maybe you give me a method in which the other person cannot compute that, right? But if we just reutilize the Mac mechanism, then everything's fine, right? The person on the other end knows the pseudo-random function, so they can recompute the tag, and everything is great. Everything is fine. So I don't understand why we need digital signatures or something different than that. So, yeah. A Mac is used to verify what you send me is what you sent to me. Yes, I agree, right? So then my question is like, what is the need for a digital signature? Right? Because I can just use Macs through, asymmetric key, asymmetric cryptography. I can just, my plaintext be my original message, comma, the thing that I have here, the pseudo-random function, right? And then just send it up to you to prevent a man-in-the-middle attack. Yes, but that's also, right, that's already prevented by Macs, right? Because, or please let me know if this is not the case. I'm just kind of confused, right? Which would be like, if I just have X and then whatever the pseudo-random function F, and then, key comma X, which, okay, I assume it may be just this fact, right? The fact that neither of us knows the key. Well, how would the other person compute the PRNG? So, I guess so. Yeah. So the key would be the one that you would need. Okay. This makes sense. Sure. If that is the reasoning, that is, we're just gonna do Macs again. It's just that we have to modify things a little bit because there is no shared key. Then sure. Then that makes a lot of sense to me. Okay, so let's keep reading. Let's see. A signature scheme will specify an additional explicit verification algorithm. A digital signature scheme, usually just called a signature scheme, consists of the following algorithms. Oh, even with the shared key, you must use a Mac still. Yeah, wait. But like, okay, wait. We may be talking about the same thing, just like different ways. Since an encrypted message can be modified while it's still encrypted. Yes, I agree. I'm saying like, if you already have the mechanism of Macs, you don't need digital signatures. Seems to me. Right, like otherwise, or maybe there's something I'm not seeing, but if you already have Mac, like Mac is equivalent to digital signatures right? In a sort of sense. Yeah. Okay. Yes. It makes sense why Mac works, because you just send this guy, and then the pseudo random function. The other guy just computes it and sees that the hash is different, and so on. That one makes sense. So digital signatures will just be Macs. It's just that it's trying to fix the problem that we don't have a shared key. So computing the pseudo-random function, which requires the key parameter, cannot be done. It just needs to be done in a different way, I imagine, right? Let's see. So we have the following algorithms. Keygen, which is a randomized algorithm that takes no inputs and outputs, a key pair, where PK is a public key and SK is a private key. Sign, which is a possibly randomized algorithm that takes a private key and message M as input and returns a signature. Okay. Then verify, which is a deterministic algorithm that takes a public key, a message M, and a signature as its input and returns a boolean. Okay. If verify of PK, M, and S is true, we say that S is a valid signature of M under PK. A signature scheme is correct if signatures generated by sign are always valid. More formally, for all M inside of curly M, the following program outputs true with probability 1. Every time you sign, verify approves it. Sometimes the public key of a signature scheme is called the verification key and the private key called the signing key. Security. The intuitive guarantee of a signature scheme is that only the private key holder can produce valid signatures. Even an adversary who is allowed to see many examples of valid signatures on messages of its choice and who knows the public key cannot produce any new examples of valid signatures. We formalize security in a similar way to Max. We imagine an attack scenario in which the adversary can request signatures on chosen messages from the victim. Let's see. The crypto nut jobs love how to separate keys for signing and verification, so be aware. Okay. We formalize security in a similar way to Max. We imagine an attack scenario in which the adversary can request signatures on chosen messages from the victim. Of course, these signatures will always be valid. A forgery is any message signature pair produced by the adversary, which is valid but different than those it received from the victim/library. We say that forgeries should be hard to generate by requiring that the verification algorithm is indistinguishable. It's indistinguishable from an algorithm that simply responds false to any MS not generated by the victim. The true verification algorithm differs from this fake one only in the case of a forgery. So if they're indistinguishable, then it must be hard to produce a forgery. Yeah, this makes total sense, right? This is just the usual definition we've been looking at. This makes sense, right? It's for you indistinguishable to see this. Okay. Another difference with Max is that we treated Max and PRFs as synonyms. Thus, every Mac that we have seen has tags that are not only hard to forge, but are pseudo-random. But pseudo-random signatures are simply not possible. A valid signature cannot be pseudo-random because it satisfies a very conspicuous property. It causes the verify algorithm to output true. A uniformly chosen value would rarely have this property. Otherwise, one could easily generate forgeries by sampling signatures uniformly. Interesting. Because of this distinction, the security definition for signature schemes does not require signatures to look pseudo-random. Both libraries produce and output truly valid signatures. We do not have a real library generating valid signatures and a random library generated fake, uniformly chosen ones. Web devs know it as JWT. True. It's JSON Web Token is what it stands for, right? If I remember correctly. Anyways, signatures from RSA. Let's go. In RSA-based cryptography, only someone who holds the private key can compute ETH roots. On the other hand, anyone with a public key can verify that X is an ETH root of Y by checking that X to the E is equal to Y. These properties seem perfectly matched for digital signatures. Can we make a signature scheme in which signatures are ETH roots? Need some coffee? A little. A little. It's just that, like, the heat makes me kind of sleepy. But yeah. Let's see. So let's read it with. In RSA-based cryptography, only someone who holds the private key can compute the ETH roots. And only someone who holds the private key can compute the ETH roots. And this is true, right? Because you're the one that holds the yes. Okay, perfect. These properties seem perfectly matched for the digital signatures. Yes, textbook RSA signatures. So textbook RSA is the signature scheme you get by letting the ETH root of M be its signature. The textbook RSA digital signature scheme is defined by the following algorithms. So keygen, signing, this is the textbook version, which is okay. You basically what? So you're basically doing the same process as RSA encryption, just in reverse. You're first attaching the decrypt, and then you're attaching the decrypt. Sorry, the encrypt, right? Yeah, so then if they are equivalent, then return false. Okay. Unfortunately, just like the case of encryption, the textbook RSA approach is insecure. Why? Why? Can we guess why? Because I honestly don't see it. First, textbook RSA signatures are malleable. Thanks to the algebraic structure given to given two textbook RSA signatures, it is not hard to see that S1 times S2 is a valid signature for the message M1 times M2. Okay, in a secure signature scheme, it should not be possible to guess a valid signature on M1 times M2 after seeing valid signatures of M1 and M2. Second, we must be more precise when claiming that it's hard to compute ETH roots mod n. In fact, it is easy to find a pair S, M, where S is the ETH root of M. Okay. Simply choose S first, and then set M be equal to this guy. Yes. In the context of textbook RSA signatures, this corresponds to an attack, in which the adversary chooses the signature first and then computes the message that matches. Even though the attack results in a signature and a message that the adversary can't control, it's something that should not be possible in a secure digital signature scheme. To be more precise about computing ETH roots mod n, we should say that it's hard to compute ETH roots mod n of values that you didn't choose. It's hard to compute ETH roots mod n of values you didn't choose. Yes, this makes sense, right? Meliodeft, do you have any favorite branch of mathematics? What? That was a huge ambulance. Do you have any favorite branch of mathematics? I would say yes. My favorite branch of math is formal logic. And it is indeed what I sort of wanted to focus on in university. Took some courses related to it. So everything related to, sort of the beginnings of logicism in a sense, right? With like logic. But I mean this not in the like propositional logic type of way that you usually see I mean this in like, you know, the compactness theorem, right? Completeness, soundness, good old like incompleteness theorems. You know, first order logic seen from the perspectives of, you know, ultra filters being used to prove compactness, etc., etc., etc. Right? So I would say that one, logic for sure, like by far, by far. So yeah. Um, Funny how you can set algorithm to RS-256 and ED25519, and RS-256 is like 10 times larger signature. Hmm. That is study of propositions and deductive arguments, right? Well, not really. It's the study of logic itself. So, like mathematical logic, it's sort of like, hmm, I feel sometimes, right? It's like if you're trying to explain to your parents, right? If your parents are like, oh, what do you do, right? You're like, oh, I do programming, right? And then they say like, oh, so you must be an expert using Excel, right? Or you must be very good at setting wallpapers, right? It's like it's like the first idea that comes to mind, and it's very difficult to see like what the actual thing is, um, from that perspective. So mathematical logic, like the name is a little bit inconvenient because it sounds like, oh, you're just proving propositions and stuff, but it's like the study of math itself. It like studies mathematics itself. It's a very weird thing. I honestly, it's like one of the most mind-boggling fields in my opinion of math, because you're using math to study math itself. Like you use mathematics to study the structure of mathematics. Um, so you have all of these meta theorems that are like extremely weird, right? Something like if you have, once again, my favorite theorem in basically all of mathematics is the compactness theorem, right? If you have the like, you know, every single sort of subset of a finite subset of a theory is, you know, satisfiable, well, or satisfies a given proposition, then the entire thing also satisfies the proposition, and then that gives you like a bunch of stuff, right? It just talks about math itself. It's like weird. It's very strange, um, but I like it, right? Andrew says my favorite is geometric algebra. Yo, pretty good, Andrew. But yeah, and Ganga came out. Hello, Rustation. Hello. I'm not sure if I'm a Rustation yet. For now, we are cryptographers, and eventually, you know, it gets to a level of Rust where I'm like, okay, you know, we're comfortable to start coding. But yeah, okay. So we're seeing here, right? It should not be possible to get a valid signature, so that's why we consider them insecure. Here we also have the thing that you're able to sort of first guess what the root should be and then pass in the message. Uh, so yeah. Yeah. Okay, okay. Um, how do you currently rate your Rust experience from 1 to 10? I feel I would rate my Rust experience. So I haven't really coded something significant in Rust, which is the problem, right? I've only been using Rustlings, and I've only been, you know, solving the compiler errors. I would say it's a 7 out of 10 right now. The reason is there are there have been like these little syntax choices that are just like very bad. Like some of the syntax choices are just like not it for me. Like, you know, I think the one that like jumps out of the screen for me is the like, we don't want Rust to have variadic functions, but we provide you macros so that you can have variadic arguments. So like, you know, it's like, if in your language design is I don't want variadic functions, then don't let there be variadic functions, right? If your macros for some reason support variadic arguments and all of that, sure, right? Maybe that's a side effect. But the fact that like the official Rust guide and language encourage you to use these macros to support variadic arguments, it's like, which one do you want? Do you want the language to have variadic arguments, or do you not want to? And so that sort of pisses me off a little, because it's like what are we doing? I would say the other thing, and this one is like very minor, that sometimes you can just not use the return keyword and it just uses the last the last expression as the return. I understand it comes from the functional programming side of things. Uh, it's just that it's like a little ah right. It's like it like to say it in a different way. I feel that when you get rid of some of the explicitness, it's like bad, right? Personally, when you keep a certain level of explicitness, it is good, right? Despite it being too explicit or something like that, it's good because like you can clearly see what's going on. So I like the return keyword because it's like return this. Without it, it's like I know people get used to it and all of that, but like it's just a little bit annoying. But that's a very minor complaint. I think my main criticism is the variadic functions. I know I've complained about other stuff too. I just don't remember it right now. I'd like to search return to jump to the end. Yeah, that's no longer possible. So, yeah. But there are some things about the language that I do consider are very good. And I think an example of something that we saw yesterday, it's well, of course, right? The memory model, pretty cool, right? How you have all the borrowing and all of the whatever. I'm sure it's gonna be extremely annoying when I'm actually coding, but in textbook it looks pretty cool because then you avoid like all of the errors and all of that stuff. What Rust was made for. But leaving that aside, I think a very good thing is Rust's match, the match guy, right? That allows you to match, sort of similar to what like basically the same to what OCaml has. I feel that's like an extremely good feature. Like I love that thing, where you're able to sort of destructure something depending on the arguments, matching, right? The usual matching. So that's pretty cool. Um, that's why I'd say it's like a 7 out of 10. I'm willing to say 8 out of 10. Okay, let's say 8 out of 10. Um, yeah. So there's that. There's also the fact that there's like 2 string classes. uh, so like that one is like, but I understand why we need it. But yeah, that's hopefully that answers your question. Yeah, let's yeah, it's quite nice and concise. Yeah, I agree, Gecko one. Um, but yeah, so let's see. Let's keep reading here. No, that's okay. I think. Okay. Odin does it much better in my opinion, though. Really? Wait, we gotta try Odin in the future then, because like our path, from what I have planned in mind, is Rust, Zig, Odin. We'll see. We'll take a look. But yeah, let's see. Second, we must be more precise when claiming that it's hard to compute e-roots of m. Oh yeah, we already read this, right? To be more precise about computing e-roots mod n of values that you didn't choose. In textbook RSA signatures, the m values can be chosen by the adversary. Oof, which means they can be chosen by known eth root. To fix textbook RSA signatures, the signer should not compute the eth root of m directly, but rather the eth root of something that nobody can directly control. That's a pretty interesting solution, right? Where we try and say, okay, right? You can control m, so you can just grab the signature first, create a message with that signature, like having that signature in mind, and then everything is sunshine and rainbows for the attacker. But if the attacker needs to compute the ETH root of something they don't have, or like something they cannot control, then there's no way they can do this sort of fixing beforehand or this pre-computation attack. Okay, RSA PSS. In the RSA PSS scheme, the signer computes ETH roots of a hash of n. Okay. The idea being that it should be hard to choose m that hashes to any favorable value. Oh, okay. Because you would be able to, if you know, if you just fix the signature, you'd be able to generate the message. But then once the hash is applied, it completely changes. So you would have to. Oh, this is very interesting. This is very smart. Okay, let's see. Let's read the chat. Try Odin sometime. You could pick it up a couple of hours just like C. That's simple. If you know how computer memory models work. Okay. RSA give me nightmares in college. No! Types of strings. Oh, God. Oh no. Is Andrew just gonna share another reason why, another Rust counter argument? Let's see. Oh yeah. Wait, this is exactly what I was saying yesterday. I think it was Mumi Jumala, where I was like, nah, C has a better model with the char star. And it's like, no, we have like, it's better if you use string because it has UTF-8, which I think it's right. I see the need for these two. Some of these are a little unfair, like this guy, this guy, this guy, this guy. But yeah, but like, it's kind of funny to see the. It's just a meme, not really an argument. Yeah, that's true. Rukasudev, hello, welcome. Hey, pretty good content. Yo, let's go. How old are you, man? I am 20 years old. I'm 20 years old. So yeah. Then, after using them. All right. 16. Oh, no, I'm not 16, dude. I wish I was 16. Yeah. No, I was just 16, but yeah. I'm still college at 20. Yeah, I mean, you have uses for all of them in some places. String is UTF-8, but sometimes you want it to be raw ASCII, and then you use array as a byte. Yeah, exactly, right. Like, it has use cases. What I was saying is, like, like, it doesn't... like, it's like, when, out of all of the things I've coded in C, I've never had the need to be like, oh my god, I'm not supporting UTF-8. Right? And for like a systems level programming language, I feel like UTF-8 is not much of a worry. But once again, that could be attributed to inexperience, and I feel Mumi Jumala was given a great argument of like, I mean, right? You can just not use it and just use vec of U8 all the time. So, yeah. Can I see your fast fetch? Your setup looks good. What is fast fetch? What? Wait, is this some Arch Linux thing that I don't know? Oh, is this little guy that people put into their... I see. It's alternative to NeoFetch. Yeah, I have no idea what these words mean. So do I just do fast fetch? There you go, I think it's the default. But yeah, it's pretty good. Like a little image of the Arch logo. Yay. Alright, let's see. NeoFetch is archived now, so this one is a replacement, but faster. How is Ghosty? Is it good? I feel it's good, yeah. I feel like I like the fact that it lets me make it transparent. It's just like, I know, like, this, Mitchell Hashimoto, like, created it and like it's really fast and everything. I honestly just like it because it's very simple. I'm not gonna use it for like crazy stuff. So I just like the fact that I can change the background and that it's very fast. So that's it. Getting strings right is very, very hard. This is a cool thread to read to get an idea of how strings can be modeled. No way, is this a live Zig discussion on them deciding the language? The language features? Dude, that's insane. Mitchell read a blog post of mine, big flex. Damn. Brother. Let's see. Treating U8 as strings is incorrect. U8 is an array of octets, not an array of characters. Zig should support Unicode more explicitly and enforce the distinction between U8 and string in the language and standard library. I propose adding a rune type, which holds one Unicode code point. The underlying storage mechanism isn't relevant to the programmer, who can only assume it's an int capable of holding a Unicode code point. On platforms whose pointers are sufficiently sized, it should probably be a U size under the covers. I also propose adding a string type, which is opaque, but of its length and indexing of runes. The underlying string encoding is also not important to the programmer, but some possible strategies include always using UTF-8 or UCS32, or upgrading the encoding as necessary to fit the runes the user attempts to place in it. Also provided should be standard library functions for manipulating strings separately from U8, and helpful functions to convert str to U8 and back again in arbitrary encodings. Very interesting. But yeah. Zig position on, oh wait. Oh my god, GitHub not working again, LMAO. Wait, is this not... I was confused, like, why is this person talking to themselves? Like, nobody responded to them, which is really sad. But is GitHub down again? Oh. Never mind, all systems operational, allegedly. Anyways. Oh, whoa. It loaded. Oh my god. 32, what? 32 remaining items. How do you define character? Oh my god. What? Crazy discussion. Okay. That's insane, dude. Like, and imagine like 2017 and they kept talking about it until 2022. That's absolutely insane. 5 years. 5 years. Damn. That's insane. 5 years talking about how to implement string. Crazy. Okay, let's see. We have Zig position on strings in which you shouldn't do Unicode formatting. For most of uses, it's not actually needed, and if needed, use external library. Let's go, Andrew. Yeah. No, but it's true. There's a lot of discussion, but GitHub isn't loading it. Yeah, it's a long thread. Yeah. Jasper, yo, hello. I'm doing great today. How about you? Yeah. By the way, Drew DeVault is creator of Heron language, which is also systems language. Damn. I remember the GitHub issue meme about a guy that only wants .exe file. Pretty good. Yo. All right. But yeah, I think Jasper arrived, so this is gonna be a great reading now because now we're gonna have Jasper to respond to our questions. I feel so bad of like relying on Jasper, being like, oh my god, Jasper is like our savior for any doubt we're gonna have. But it's kind of true. Let me take a look at Hairline before we continue reading. Oh, what is this guy? Wait, I want to take a look at this image. Oh, that's cute. Interesting. Simple, stable, and robust. There uses a static type system, manual memory management, and a minimal runtime. Operating system tools, compilers. That's crazy. So he, like the designer of this, went to Zig and said, like, trust me, right? That we need to do it this way. And then everybody was like, yes, no, yes, no, yes, no, yes, no. Hair fits on a 3-inch. What? These will be available for purchase when Hair 1.0 is released. Oh, wait, that's actually pretty cute. That's very good. Which is also crazy, right? Given the modern, you know, the modern tendency to just have everything be like as heavy as possible. But yeah, excellent, excellent. Um, let's see. Funny how his example on main page is Unicode example. Yeah, yeah. I was taking a look at these characters and I was like, damn. Nah, that's fine. The fact that you're doing crypto and I'm glad to help. Yo, let's go. Herod's great. I've written firmware. Yo, I love physical media. And where do you even get a floppy reader? That is a great question. Where do you even get one? I guess it's like still good, to have it and be like, this floppy disk contains hair. Like, it's pretty cool too. To tell somebody like, oh, I have a copy of hair, like this little floppy disk. But yeah, let's see. Let's continue. All right. So this one we already read. Here. So we're entering RSA PSS. So in the RSA PSS scheme, the signer computes the ETH roots of a hash of M. The idea being that it should be hard to choose M that hashes to any favorable value. So we saw what the what the reasoning behind this was. If you have sort of the possibility to compute ETH roots, everything is great. If you are the attacker, you just choose a signature and then you make the message be the ETH sort of power of your signature. So that when the message is decrypted, then it becomes, an ETH root. Which is, pretty interesting. Yeah, and so if you ask sort of the sender to compute the ETH root, but not for a value they can control, like the M, instead a value that they maybe don't have control over, which would be the hash, then it is very, it's very difficult for them to do this. You get a lot of USB devices on eBay and Amazon. Really? Oh wait, that's good then. Didn't know. That's cool. Yeah, lucky us exists. Yes, that's true. All right, let's see. In the RSA PSS scheme, the signer computes the ETH roots of a hash of M. The idea being that it should be hard to choose M that hashes to any favorable value. This makes total sense. The signature scheme can be proven secure if the hash function is modeled as a random oracle. The proof is made significantly easier if the signer computes an ETH root, not of H of M, but of H of M, attached R, where R is chosen uniformly for each signature. So basically, we are salting the hash function in a sense, right? So we salt it with some random value. And then we need to remember what that random value is. So we also need to remember the salt that we used. Okay, let's take a look at the construction. So let H be a random oracle whose range is Dn. The RSA probabilistic signature scheme is defined by the following algorithms. So we're able to sign something. We sign it by saying, okay, give me the private key and give me the, whatever you want to sign. We choose a random R. We use it to salt sort of our hash function, and the signature is just going to be the sort of the power of that hash. Okay. Then we return R and S. To verify, we have the public key, we have the message, and we have the signature, right? Which signature would have to be sort of these two guys, right? Like S alone is not the signature itself, right? I mean, like it is, but in technical terms, this pair is the signature, although this little guy is supposed to be the one we think of as signature. Anyways, verify, let's see. If S to the E is equivalent modulo M to the hash of M adjoint R, then return true. Which makes sense, right? This is going to be sort of the signature when you raise it to the power of E, it gives you back the original values, you're able to recompute it, and then you're able to return true. That's pretty decent. And this is basically doing the job of a Mac, right? Where we sort of recompute the hash function and, well, the pseudo random function, and then see whether or not the output is the same. Here we cannot use pseudo random as it was mentioned before, but it's okay. So let's see. Okay, textbook RSA wouldn't work because of this. But we solved the problem by making it so that the thing you need to create an ETH root for is the hash. This R is just attached for convenience, but the proof should be possible without R, I imagine. Okay. One downside to RSA PSS is that it requires a hash function that acts like a random oracle with outputs in Zn. It's not immediately clear how to instantiate such a hash function in the real world. However, this construction is merely a simplification of the real RSA PSS standard, which uses a more conventional random oracle with outputs in strings of size lambda. So imagine, like, right, because one thing, please correct me if I'm wrong, but imagine if we don't include the R, then we could have the problem of pre-computation attacks, where you're able to sort of, well, actually, would you be vulnerable to some sort of pre-computation attack? I actually don't think so. If we remove R, then it is still pretty difficult. Like, even if you know what the hash is going to be, it is still hard to know what. Yeah. So R is just there for the convenience of the proof, it seems. It seems like we don't really need it for correctness, although it may be more difficult to prove and whatever, but yeah, it seems like we could just do this without R. Right, because computing the hash, the only reason we compute the hash, it's just that we want it to be a value that cannot be chosen by the attacker. Or like, yeah, that the attacker cannot control, right? Because before, the attacker could control the plaintext, and so they just fabricate an ETH root. Here, independent of whether or not they choose the plaintext, they cannot really make the hash function output something that's favorable to them. And so the problem is still reduced to trying to find an ETH root for this guy, which is, a hard problem. Yeah. So immediately clearly how to okay. One downside of RSA PSS is that it requires a hash function that acts like a random oracle with outputs in Zn. It's not immediately clear how to instantiate such a hash function in the real world. However, construction 16.2.2 is merely a simplification of the real RSA PSS standard, which uses a more conventional random oracle with outputs in 0, 1 lambda. Okay, let's see. No, we even trying to make it look like some of China's stuff is made by us. That's true. Me, after being able to run DeepSeek locally and have a good private model, lucky me, China exists. Brother, you are not American enough. Alright. Self-reducibility. Let's see. In the RSA assumption, one RSA key pair is associated with just the single challenge value y. Finding the ETH root of this value y is hard. On the other hand, the security of RSA PSS relies on the difficulty of finding the ETH root of any one of many random oracle outputs. Hence, one important step in the proof is to bridge this gap between one target for ETH roots and many targets. In this section, we prove that finding the ETH root of any one of many uniformly chosen targets is hard. This is a general result, not tied to the use of RSA for signatures. The proof uses the following idea. Given any RSA target value y star, there is a way to generate many new values y sub I such that each yi is uniformly distributed in z star n. And given the ETH root of any of these yi values, we can easily compute an eth root of y star. There is a way to generate many new values yi such that each yi is uniformly distributed and given the eth root of any of these yi's. Okay, thus from a single target value y star, we get many target values yi, which follow the correct distribution and whose eth roots are exactly as hard to find as y stars. This kind of transformation from one y star to many yi's is called a random self-reduction, and it is a useful concept throughout cryptography. Okay, let's see an example. Let's now see the idea behind this self-reduction, illustrated for a single y value. Given a target value y star, how can we choose y such that an eth root of y helps us learn the eth root of y star? Okay, let's see. Suppose y star, y, and delta belong in Zn star, where y is equivalent to y star times delta to the e. Okay. Then given delta and an eth root of y, it is possible to efficiently compute an eth root of y star. Furthermore, if this guy is sampled uniformly, then the distribution over y is uniform. Because if you have a root for this guy, then you get that these guys to the power is equal to 1. Yeah, you invert it or something? Let's see, proof. If x is an eth root of y, then x star, which is x times this guy, is an eth root of y star. A fact that can be verified as this happens, right? So x star to the e is equal to this, which is equal to this, which is equivalent, oh yes, it is an eth root of y, so yes, good to convert it. Y is the same as this guy, and then they get cancelled. Okay. So they just gave us, right? They just gave us y, it's very easy to find an eth root. Okay. Perfect. To see that y is distributed uniformly, observe that 1, delta is chosen uniformly. 2, raising to the eth power is a one-to-one function, so delta to the e is distributed uniformly. Y is equal to this guy is a one-time pad ciphertext. Whoa, yeah. With delta e acting as key and multiplication mod n as the algebraic group operation. Wow. This is true. Okay, we can now prove the multi-target security of the RSA assumption. Here, if the RSA assumption is true, the following two libraries are indistinguishable. Okay. In the real one, we grab, okay, this is the RSA challenge. Grab a random value from Zn, attach it to our set, and then return y. Then if this is an eth root that belongs inside of y, then return true, otherwise return false. Ideal would be, okay, so they're indistinguishable. I see, so like independent of what you do, however many you compute, if you're able to compute polynomial many of them, you're not going to be able to hit one, right, in polynomial time. Yeah, these libraries are indistinguishable if it is hard for the adversary to find the eth root of any of the y values generated by the library. Hybrid sequence. So we start from real. What do we do next? First, we write the check for membership in y as for loop involving explicit comparisons. Okay, for each y, return true, return false. Okay. Y, where is this guiding us? Suppose we initially choose one value y star and later define each y as this guy. If each delta is uniformly distributed, then the y's are also, yes, this is true. In RSA check, we can then replace each y with its equivalent expression. Instead of keeping track of a collection of y values, it is then enough to keep track of their lambda values. This is true, and this makes sense. We sample a delta. This sampling is, the same, or can be used to just sample a y. And yeah, this makes sense. Now we can rearrange the equation x to the e. Okay. Yes. Okay. Now the library has a single target value y star and repeatedly checks whether a certain expression is its eth root. We can therefore apply the RSA assumption, with y star playing the role of its single target value. The standard, ooh, okay. And then you're able to, yeah. This guy gets compressed to something nonsensical, so you're just able to return a false. Yeah, as we argued above, each y value is sampled uniformly. Now that the delta values are not needed, we can simply sample the y values uniformly in a more direct way, as they were previously. Yeah. Perfect. Wow. Yo. Security proof for RSA PSS. We now have the tools to prove the security of RSA PSS. This guy is a secure digital signature scheme in the random oracle model, if the RSA assumption is true. Alright, an RSA PSS signature is the eth root of a random oracle output. Yes, the intuition behind security is that it is hard to compute the eth root of such uniformly sampled values if you don't know the private RSA exponent d. We expect to formalize this intuition in the security proof by applying this claim, but you cannot do so unless we have a hybrid library that doesn't use d at all. The libraries in this claim do not provide d to the calling program, so the main challenge in this proof is finding a different way to implement the 6-line subroutine without using d. Oh, what? Okay. Our approach takes advantage of the fact that the library can change how random oracle outputs are generated. This is called programming the random oracle. Normally, the 6-line subroutine would sample h of m adjoint r uniformly from Zn. This is true. We introduce a hybrid in which the library samples this h of mr to have a known eth root. In other words, when this guy is called, the library samples s, computes x equals s to the e, and designates x to be the output of this guy. The output distribution of this does not change, it remains uniform. However, R and S is a valid RSA PSS signature of M, because S is the eth root of the hash. Importantly, this modified library never needs to know the exponent d. Okay. It just samples a random signature, takes it to the power of e, exponentiation is a 1-to-1, so it's still uniform. So the outputs are still uniform, which makes sense. And whatever the hash outputs, you'd be able to find the original signature S by powering it to the power of d. Okay. Because S is the eth root of this guy. Okay, yeah. However, S is the eth root of that guy. Importantly, this modified library never needs to know the exponent d. I see. So you're able to then apply d to this, get the original S, take it to the power of d, and then send that. Maybe? Wait, no, you cannot use d. Okay. At this point in the proof, random oracle calls are treated in two distinct ways. If a random oracle call is made inside 6-line, then the library chooses the output in a special way to have a known eth root. If a random oracle call is made directly by the adversary, then the library chooses the output uniformly. So we can argue that finding an eth root of this value is hard. You may ask what should happen if a random oracle call falls into both cases. Yes. Should the output be chosen with a known or unknown eth root? Fortunately, we don't need to worry about this case. What? The first case involves calls of the form h of m adjoint r, where r has just been sampled uniformly. It is therefore only negligibly likely that the adversary has already directly called that guy. So that's why the proof is easier. I see. This is precisely the reason for our... yeah. Okay, we now proceed with a hybrid proof. So the starting point is real plus RO. So we... okay. this is the usual, the keygen, the PK is fine. To sign them, we retrieve a random value, This is what we already saw. Okay, perfect. Okay. The library can remember signatures produced by 6sign. They don't need to be verified later in 6var. Yes, this is true. If wait, what was the proofs? Okay, yes. Inline the call made to H inside 6sign. Oh, what? Okay. Make the if statement in 6sign unconditional. This changes the library's behavior only in the bad event that this guy is already defined. However, R is sampled uniformly each time. If the adversary makes at most Q calls to the library subroutines, then there are at most Q entries in H. So at most Q bad values of R that can be chosen. Overall, across at most Q calls to 6sign, the bad event has negligible probability of at most Q squared over 2 lambda. Okay. Instead of uniformly sampling this guy and setting S to it, we can uniformly sample S and set this guy to be S to the E. The two methods induce the same joint distribution. This is what we mentioned before. So yes. When sigvar checks whether y is equal to SE, it always uses a y that was chosen uniformly in H, not chosen with a known ETH root in 6sign. If we let y, curly y, denote the set of all H outputs, then the condition y is equal to SE implies that SE belongs in y. Hence, it has no effect on the library to add the additional check SE belongs to y in sigvar. Agree. Agree. The library no longer uses the private RSA exponent D. It maintains a set y of uniformly sampled values. It later checks whether the adversary has provided an ETH root of any of these values. Hence, we can apply claim yes. Perfect. Then we continue. After this replacement, the code gets changed. Yes. Okay. After removing the now unreachable if statement and reversing several earlier changes, the result is the fake one, which completes the proof. Whoa, what was the change? If false, okay, yeah, impossible to reach. These guys can just be sampled normally. Okay, that makes sense. Wow, pretty good. Yay! A note in programming. Programming the random oracle is a powerful proof technique, and one of the main features of the random oracle that critics disparage. Indeed, imagine trying to carry out the steps of a security proof where H is a public, plain model hash function like SHA-3. You will get stuck when the proof reaches a hybrid that tries to choose SHA-3MR to have a known ETH root. Of course, the library cannot do this, because SHA-3MR simply is whatever it is, and the library cannot pretend it to be something else. A rant. If you want to make a cryptographer genuinely angry, casually mention that sign-in is just encrypting with the private key, or that verifying a signature is just decrypting with the public key. The document is then encrypted with the user's private key. Okay. US News and World Report. Okay, to validate a digital signature, the recipient decrypts the digital signature using the sender's public key. Public key encrypts, private key decrypts. This is encrypting. Private key encrypts and public key decrypts is signing. Highly rated answers the Stack Overflow question, how does public key verify a signature? You can create a one-way hash of the data and then use your private key to encrypt the hash. The encrypted hash, along with other information like the hashing algorithm, is known as a digital signature. This is the IBM Z/TPF documentation. Why do people say these things? RSA-based cryptography, for both encryption and signatures, involves exponentiation to the E power and to the D power. Okay, we exponentiate with E, yes. In a non-technical context, we might want to avoid talking about the scary concept of exponentiation and instead euphemistically refer to it as encryption-decryption with a key. In that case, it would make sense to describe signing as encryption with the private key. This correctly emphasizes the fact that encryption and signature verification use public information, while decryption and signing require private information. So what's wrong with saying these things? First, it's annoyingly imprecise to call everything encryption and decryption. Digital signatures and public key encryption are completely different primitives, targeting completely different security goals. They deserve different terminology. If an operation requires the private key of a public private key pair, please still call it encryption. Second, it is wrong to suggest the fundamental duality between signature schemes and encryption schemes. That is, to construct a signature scheme, just reverse the keys in a public key encryption scheme. Yay. The fact that RSA encryption, decryption, signing, and verification all use similar exploitation steps is mostly a fluke. There is no fundamental reason to expect a signing algorithm to resemble any kind of encryption operation. Aside from RSA, I can't think of any other signature scheme with this curious property. In general, you cannot easily convert an arbitrary PKE scheme into a digital signature scheme, nor vice versa. Yo, looking ahead. RSA-based signatures have great historical significance, and the security proof demonstrates important new provable security techniques. However, RSA signatures are expensive and large because RSA requires huge moduli. One might wonder whether, as in the case of key agreement, it is possible to achieve something better by using elliptic curve cryptography, where the underlying values are significantly smaller than RSA group elements. Later, in section 19.4, we discuss an alternative approach for signatures, called Schnorr signatures, that can be based on elliptic curves and therefore lead to much smaller signatures. For most applications, Schnorr signatures, in closely related constructions, are a better choice than RSA signatures. Okay. Common signature idioms. Hash, then sign. In RSA PSS, the signer starts by computing a hash of the message being signed. It is important to the security proof that the hash function is a random oracle. But the idea of hashing before signing is a standard general principle. In practice, one can always sign a hash of a long message rather than the message itself. Signing a hash authenticates that the signer vouches for that hash, and if the hash function is collision resistant, there can only be one known message that produces that hash, so the signature of its hash authenticates that unique message. But the signer and verifier must be able to evaluate this hash function. Thus, one should use standard collision resistant hash function with public salt and not a UHF. We can formalize the security of signing a hash with the following construction. Okay, I mean, this sort of makes sense. Like, it's a very intuitive sort of thing to take a look at. Certificates and chains. Ooh, let's see. When Alice wants to connect to joyofcryptography.com, how does her browser ensure that she's talking to the real joyofcryptography.com and not some imposter website that advocates for ECB mode? Cryptography does not directly involve things like website domain names. Instead, it involves public keys and private keys. Users need a way to bridge the gap between cryptographic public keys and human understandable identities like domain names. On the internet, this gap is bridged by certificates, a common application of digital signatures. Certificates help answer the question, what is the correct public key for this particular domain? Later in chapter 18, we discuss how to actually use a public key to cryptographically authenticate a website connection. There are billions of websites, so web browsers cannot simply ship with a database that maps every domain name to a public key. To a set of public keys. Instead, browsers delegate the responsibility to a small number of certificate authorities. The job of CA is to issue certificates, which are essentially digital signatures and messages of the form A28F1 EB9 bar is a valid public key for joyofcryptography.com. Certificates are issued in the following process. A website operator contacts a CA and presents a public key. The operator proves that it controls the domain name, usually by adding a special string to its DNS record or to a publicly accessible web page, and 2, that it controls the public key, usually by signing a challenge message sampled uniformly by the CA. Okay. Sure. If the CA is satisfied, it will generate a certificate signed under its public key. Okay. This process is frequently automated, and some larger website hosting companies are also CAs themselves, making the process easier. Later, when a browser connects to the website, the web server presents its public key PK and its certificate. The browser verifies that the certificate lists PK in the expected domain name and that it is signed by a known CA. Each browser ships with a small collection of known CA public keys. At the time of writing, my browser recognizes 74 CAs. That's very little. It seems to me, right? It's very little CAs. Assuming all of these checks pass, the browser attempts to authenticate the server as the holder of the private key corresponding to PK. Authentication happens using the techniques described in Chapter 18. Okay. The question, I guess, becomes a little bit recursive, where it's like, how can you trust that, that is an actual CA? Do you just rely on the normal world where it's like, yes, bro, trust me. Like, I am indeed a CA, and you can come to my office and see everything, and I'll show you there that I am an actual CA. Signature and certificate chains. Let's see. You can't really. Sometimes they are hijacked. Yeah, that's what I imagined. That's insane. Okay. I guess so, yeah. I guess it's like, you cannot have turtles all the way down. At some point in time, you're going to have some sort of trust. But I feel it shouldn't be this way. Are there any alternatives? Maybe that's something we can explore later. Let's see, signature certificate chains. A certificate is just a signature vouching for someone else's public key. That someone else could be a website, but it could also be another CA. In practice, root CAs sign the public keys of other CAs, called intermediate CAs, who then sign the public keys of websites. This arrangement helps relieve load on the root CAs. For example, the certificate for joycryptography.com is signed by Cloudflare CA, whose CA certificate is signed by Baltimore Cyber Trust, a root CA whose public key is in your browser's trust tool. When your browser connects to joycryptography.com, the server presents its public key along with its certificate chain. Your browser validates the entire chain from root to website. Wow. Trusting CAs. You can try and look up which CAs your browser actually has. Yeah, we should do that. Let's finish this section and we try it out. Trusting CAs. Any certificate authority, that your browser trusts can issue a certificate for any domain name. Thus, CAs have the power to completely and silently impersonate any website on the internet. This seems so bad. The decision to include a CA in a browser's trusted list is therefore not taken lightly, and geopolitical forces are often at play. The EU recently proposed controversial legislation that would force browsers to trust CAs operated by EU governments. What? A rogue CA who issues improper certificates can have a disastrous impact on the internet. While rogue certificates cannot be completely eliminated, modern web browsers include some features to detect them. For example, a website operator can instruct browsers to accept certificates only from specific CAs using a special DNS record called Certificate Authority Authorization, or CAA. In a project called Certificate Transparency, CAs are required to publicly announce all certificates they issue. Some browsers periodically check certificates they have received against this public list. A domain name owner can also check the list for unexpected certificates for their domain. If a website presents a certificate that is not on this public list, the offending CA's reputation can be damaged. And that's the end. This is a very bitter end to such a beautiful chapter. I believe, how, I guess all of this wouldn't be necessary if we didn't have to rely on domain names, right? Because then you could just use the sort of like an onion router sort of thing, right? Where you just have the onion URL, and that's the only thing you know. Interesting. In Russia, since a lot of companies can't get proper certificates, they ask users to add government authorized CA to the list, since it's not default in some browsers. Oh no. Dude, that's so sad. Okay, so this is another criticism against the CA model, right? Because then CAs could just say like, oh, because of geopolitical problems, I'm not gonna allow people from this side to certify their websites. That's insane. And this is the platform over which the internet, the modern internet relies on? That's crazy. What? Okay, guys, we're gonna have... I mean, I don't know much about Tor. I do imagine Tor does not have this problem because, like, the problem doesn't exist in the first place, and you don't really have domain names. You only have, like, the actual bare address. Correct me if I'm wrong because I know nothing about Tor other than the, you know, the sort of landscape view of things. But if so, we are creating a stream soon, downloading Tor, using Tor from scratch. But yeah, that is absolutely insane. And kind of sad, right? Sort of defeats the whole purpose. Well, I guess it doesn't defeat the purpose, right? It is not in the purpose of the internet to not be, like... Well, I guess the purpose of the internet is to not be centralized, so CAs sort of go against that. But, like, the modern internet is currently, like, centralized by a huge amount and controlled by very small and specific organizations. So this doesn't go against that, but it's definitely not what we want. At least I wouldn't want that, right? If you were to create sort of an ideal world. Interesting. Well, guys, officially, we have finished the required chapters for Joy of Cryptography. Yay! Yes, exactly! What Andrew is saying. I was like, how do you actually... Because this is just turtles all the way down. If you cannot trust... If you're saying, let's introduce CAs, which are organizations, to verify that this guy is true, then how can you trust the actual CA, right? I mean, they explained it here, right? Like, oh, you know, browsers just include it as a hard-coded list, and they're gonna... Brother. You know, it's just turtles all the way down as usual. So these problems would be solved if we were just using not normal browsers. We're just using something else. But yeah, let's change the internet, guys. Alright. Well, this was a fun read. This is a very good read. Thank you, Andrew specifically, for sharing this resource, Joy of Cryptography, with us. Everybody, kudos to Andrew. Andrew already has VIP because of this. We did this like 2 weeks ago or something like that. But yeah, this is great. Yo, you know what that means? It means, first of all, it's time for the Rust. Second of all, we're going to be able to take a look into the Bitcoin white paper. Try to find how many companies you recognize in the list of your browser CAs list. That is true. Let's see. How to retrieve my browser's certificate authority list. Firefox. Open the browser menu. Click settings. Click settings. Oh wait. Open the browser menu. Click settings. Search for certificates in the settings search bar. Ooh. Click View Certificates. Manage certificates, I imagine. Ooh, default trust, default trust. Okay, it's these guys. Akvirazi, no idea. Actails, Trust, Amazon, Amazon is controlling the 4 of them. Certum Trusted, Atos, Autoridad de Certificación Firma Profesional CIF A62634068. Beijing Certificate Authority. Bypass. Certainly. I have no idea what. China Financial Certification Authority. Chunghua Telecom Co Ltd. Komodo CA. Cybertrust Japan. Not a single one recognized. Demiotis. Digicert. Whoa, Digicert has a lot of them. Digital Sign. Disig. Emudra Technologies. And Trust.net. I wonder what they are trying to bypass. What do you mean? Entrust.net, FNMT. Yeah, why do they have so many? That's okay. Global Sign again. GoDaddy, Google Trust Services, Guangdong. It was one of the companies. Oh, sorry. Hellenic Academic and Research Institution. This is in Greece. Hong Kong Post, Eden Trust, Internet Security Research Group, I Trust China. I do not trust China. Okay, Krajowa Isva, Rosli. Oh, I cannot read this. I don't know how to pronounce this. Law Trust, Microsec, Microsoft Corporation, Naver, Netlock, Oyster Foundation, Quo Vadis, Secom, Sectigo, SSL Corporation. I did not know there was such a thing as the SSL Corporation. Swiss Science, Starfield, Taiwan CA, Telia, the GoDaddy Group, the User Trust Network, Trust Digital Technologies, Turkey, Unitrust, Uniceto, WiseKey. Where is Cloudflare? We did not see Cloudflare, guys. Is it good? Is that good or bad? I don't know. Oof. Alright. Yo. Pretty much same scheme with DNS as well, I imagine. That's so bad. No. Anyways. Everything just to support domain names, which is crazy. But anyways. By the way, it's not called TLS, not SSL. Seems like they didn't update the company name. Oh. It's now called TLS, not SSL. Okay. Interesting. But yeah. Alright. Yo, this was excellent chapter, excellent into the series. I think this is appropriate for us to take a break. A little 30-minute break. So after the break, we're going to continue working, but this time with Rust. So we're going to be working on Rust. This is going to be very exciting, as usual. So how much is 15 minutes times 60 seconds? That's 900. So it's probably 1800. Okay. How many emergency vehicles are under your windows? That is a great question. I've heard 3 ambulances today, which is a little bit concerning. But yeah, alright. Alright, guys, let's do that. Let's what's the name? Let's have a small break, okay, of 30 minutes. Let me edit here the starting soon screen, and let's come back in 30 minutes. Alright, we're gonna start with Rust then. See you, everybody. Hello. Hello, everyone. Welcome back. Oh, hopefully you all had a good break. I did, just relaxing. Sort of after reading a while, it gets a little tiring. Yeah. So I'm trying to see, well, is the audio being captured by the air?
Hello. Yes. Let's see.
Default?
Oh, it wasn't using my. Okay, it seems like it was the camera that was being used. So now it should sound better. Hopefully. I'm not sure. You guys should let me know if it sounds better or not. But yeah, so let's now start sort of learning Rust. I would say Rust. Let's start learning Rust. All right. Coding scene. Yay. So go to workspace one, and in workspace one, I think I have the Visual Studio Code. Perfect. So I have this guy, but I was looking at it before, but yeah, no. Okay. So we have. Okay, my thing with this is like there's so many of them. Like so, it just feels so daunting. But it's okay. It's okay. So let's just run Rustling. Let's do this for like 30 minutes, and then I think we can start sort of writing our own encryption decryption little guy. Okay. So yeah, in Rust. Let's see. Okay. So working with strings one. All right, fix the compiler error without changing the function signature. So this guy, of course, it's a string from this guy, not from. It's a from. And I just do return. Perfect. All right, next. Next, fix the compiler error in the main function without changing this function. Okay, let word be this guy. Then if is a color word, this is supposed to be a reference, so I just pass a reference instead. Yes, great. Strings 3. Let's see. Oh my god. Remove white space from both ends of a string. Add. Oh, okay. So these are actually practical. Ooh, okay. Replace cars in the string with balloons. Oh my god. Okay, let's see. Remove white space from both ends of a string. So I imagine that there are Rust functions to do this, no? If I do input dot maybe trim, input dot trim, is that what would be ideal? Returns as lines with leading and trailing white space removed. Interesting. So it returns as lines. So that's what we need to return. Perfect. Add well to the string. There are multiple ways to do this. So I imagine that if I have a reference to a slice, we could do something like what? So it could be string from, and then I'm gonna return this. Oh shoot. Okay, from input, and then to it I can add the word world. Something like that. Is that allowed? Yes, I imagine like this would be a string from to, but like maybe it just does automatic casting is what I assume. Because I imagine if I do this, then it's gonna be wrong. Yeah. If I do this, then we'll find. Then replace cars in the string with balloons. So I imagine I can do input dot replace. Yes. Replace. Let's see. Replaces all matches of the pattern with another string. Replace creates a new string and copies the data from this line. Okay, yeah. What is from? this is new, and then s dot replace old with new. Then an old. Okay, this is new. Oh, okay. So this is okay. What is the thing I want to replace? And what? Okay, replace cars with balloons. Perfect. Does it return something? Yes. Replaces all ventures. Oh, it creates a new string. Ah, okay. And then we return this guy. Perfect. Yay. Okay, next. Strings number 4. We're speed running this thing. Calls of this function should be replaced with calls of string size or string. Okay. Here are a bunch of values. Some are string, some are ampersand string. Your task is to replace placeholder with either string size or string, depending on what you think each value is. Oh, okay, so they're just testing my knowledge. Okay, this one is a string slice, for sure, right? Let's see. Kenya Kamau says, way back getting rusty. That's true. Oh, Rust exercises. Yo, wait, this could be really helpful, actually. Wait, let me take a look at this quickly. Let's put the URL. Oh, this is exactly what I was looking for. This is exactly what I was looking for. Kind of like I wanted to have like a little thing, like a little project that for from which to learn like the actual Rust. Okay, let's do Rustlings for like until 4:30. You can see the time here up here, and then we can just transition to one of these, or we can just go to the cryptography directly and try to implement it. Yeah, this one's a string. This guy is a string. This is, oh, to own creates owned data from borrowed data, usually by cloning. So why don't we just use clone? Why does this guy even exist? Can't we just call the own, like clone? I mean, if it's data we own, then it's a string. Into, what the hell is into? Expected converts this type into the usually inferred input type. What? What is... It's a method from into trait, and it converts the object into a different type. Rust supports method overloading and return type, so what type the conversion is done into depends on context. For example, in this guy, the implementation of into for i32 is called and the integer is converted into a 64-bit floating point number. Worth noting is that there's also a reverse of into trait, which is from, which constructs a type from an argument. What? The microphone is worse compared to before the break. Interesting, because this is the microphone I would always use before I moved here. But
this is the microphone that I was using before. So let me know which one's better, which one's worse.
This guy is the AirPods.
This guy is the computer. So let me know which one you consider to be the best, and we can just use that. But yeah. Alright. Let's see, from into TLDR, it is whatever you want it to be, hopefully. No, because the into method is not generic. The into trait is. What the fuck? The from and into traits are inherently linked, and this is actually part of its implementation. If you're able to convert type A from type B, it should be easy to believe that we should be able to convert from type B to type A. Computer has some background noise, but voice quality is better. Okay, that's fine. Let's leave computer then. The from trait allows for a type to define how to create itself from another type, hence providing a very simple mechanism for converting. Let's see, there's a slight difference. One sounds muffled, this one is clearer. Okay, let's use this one then. For example, we can easily convert a string into a string. Oh wait, we've been using the from trait all this time. What is into? It's simply the reciprocal of the from trait. It defines how to convert a type into another type. Okay, what the hell is this? Implementation of into number for I32. F into and the number value self. Let num number in dot into. This is. I hate this. I hate this. I don't want this. What is this into supposed to do here if I am not providing any sort of type? Does it just keep it the way it is? So I imagine it would be a string slice. Yeah, if I try doing a string, will it complain? Oh, it doesn't. Okay. My guess is this is a string slice. It looks up type from function argument type. Oh. Oh, so it doesn't matter what I put in. Yeah, that's bad. Format, interpolation, then station. I imagine this has to be a string. If I were to try a string slice, would it let me? Yeah, no. Okay. That's string. So all of our guesses have been correct so far because we've never faced something like that. Warning, this is byte indexing, not character indexing. Character indexing can be done using SDHARS and... Brother, we just saw... What? Am I being lied to? Rust, which one is it? Which one is it, Mr. Rust? Because if we go... I'm very sure I read this. Very sure I read this. Wait. Strings, Rust book. The Rust book, where is it? Here. Here, common collections. Creating a new string. Where is it? Updating a string. I need the indexing part. Indexing into strings. Here. Here, where is it? Rust strings don't support indexing. Anders, you can't easily slice strings because they are UTF. Yes, we read this yesterday and right. And what I'm saying is this kind of contradicts what was being said from yesterday. Rust strings don't support indexing. I guess this is not indexing, this is slicing. But this is indexing. Because it's just grab the first one. Because this is an exclusive thing. So this is just grabbing one of them. So this is indexing. So here it's Rust strings don't support indexing, and then comes this guy and shows me this. Right? I understand. Right, this is byte indexing, not character indexing, sure. Right, sure, I agree. But why is this a possibility in the first place if we are intended to not use indexing with strings? How am I supposed... Am I just interpreting it wrong? Because this straight up should not be a thing. Chars give you an iterator and nth gets the nth element of iterator. This is not indexing since it will iterate through entire string to get an element. It's off an operation. It's not indexing, since it will iterate through the entire string to get the nth element. It's an O(n) operation. That would be chars, right? Chars is the one that you're telling me. As.chars.nth index, makes total sense. Right? Like that guy, this guy here, sure. Agree. Completely. This guy, why? Like, what are we doing? Right? Like, yes, this is byte indexing, but like, you're literally indexing a string, which is what we were supposed to not do. You're indexing the bytes, yes. But like, what? You're not sure this is valid. Okay, I see. So this is, yeah, I would theorize the same, right? This shouldn't be valid. So I imagine, what happens if I just write string? No, dude, this is valid. Found the string slice. This is a slice of a string. Like, like, okay, like yes, I understand this is a byte thing, right? But like this just shouldn't be possible. Oh my god, but like it's an actual thing. It's an actual, it's a sequence of bytes. Strings are actually sequences of bytes, and the shut up. We're talking about the syntax here. Like, Rust, what are you doing, bro? Because like it would be. Once again, I feel this is like the problem I'm having with this language. This language is like slowly but surely rage baiting me. Because if you want to do the byte indexing, I feel it should be required of you to do something like dot bytes and then actually do the indexing or something like that, right? But like doing it this way, it's like the most confusing sort of. Maybe there's a reason behind it. Maybe my ignorance is tricking me. But this is like the actual worst thing you could do when the official Rust book says Rust strings don't support indexing. Why not? And then they provide an entire chapter on why indexing on strings is confusing and shouldn't be done. Like, this is. Sure, there's like the section on the slicing strings, right? But like, containing particular bytes, yes, right? But like, I'm going to kill everybody on the Rust development team. Okay, no, of course not going to do that. Let me see what Andrew sent. Exited with status 101. Oh, what? Compiling playground, hash set. Okay, first of all, why are we using a hash set? Oh. Okay, whoa. I do not understand what's going on because I haven't played with Rust. Warning, playground, generating one warning. Finish def profile, Thread main panicked at line 5. End byte index 1 is not a char boundary. It is inside n. Note. Ignore hash set. It's left from previous text I had in the playground. So do I remove this guy hash set? I'm so sorry. It's just that I don't know how to use Rust because I haven't coded in it much. I think I just delete this guy and then I delete this guy too. And then I run again. Oh shoot. The 1 first line. So that thing, I still include the HS. I imagine. Third main end byte index 1 is not a char boundary. It is inside this character. So it's telling us like, yes, you can do this. Well, actually, it's telling us like, no, you cannot do this. Because you're indexing. What? Okay, so which one is it? Is it yes, you can do this, or no, you cannot do this? Because what they're saying here is yes, you can extract, right, a slice by doing this, right? Yeah, you can create a string slice containing particular bytes. But when I tell it I want the first byte, it's gonna tell me, no, you actually cannot do that. You need to, what the hell? Okay, let me read this. Here, S will be that contains the first 4 bytes of the string. Earlier, we mentioned that each of these characters was 2 bytes, which means S will be this guy. If we were to try to slice only part of a character's bytes with something like this, okay, Ross would panic at runtime in the same way as if it. Yes, okay. You should use caution when creating string slices with ranges. Can crash your program. Okay. Help me understand this. Like, you can, but it will panic if you don't know the content beforehand. So it seems to be of primitive. Yeah. But like, okay, help me understand this. It will not let you create, sort of extract the bytes of a string if you just so happen to not extract the full character, right? That means that byte indexing is out of the question because it just won't let you do it if you don't grab the whole character. So tell me why, if byte indexing is out of the question, why don't we just use character indexing and make this guy symbolize character indexing? Because if you're not going to let me do otherwise, then there's only one option left. Maybe there's other options which would invalidate what I'm saying, but like, why even create this in the first place then? Char indexing is so often. Yes, right? But like, then why create, like... Okay, no, I see what you're saying. But it just like... This just shouldn't be a thing. Like, I just feel this just makes the language more confusing. Right? The slicing, yes, I see your point. Now. But... I don't... Okay. Hear me out on this one. Never mind. Never mind what I was gonna say. Because what I was gonna say was, right? You can only apply this when you know what the content of the string will be, right? It means that you cannot apply this on input, or it would be completely unsafe to apply this on input, and thus Rust should prohibit it. Therefore, it means that you only use this when you actually know the contents of the string. But if you know the contents of the string, it means that it has been declared in the program. So the compiler already knows what it is. So then we can support sort of the character indexing just by pre-compiling where the thing would be. But that's not the case, of course. But yeah. Right, because then you could say like, oh yeah, just let the compiler make the computation beforehand, and then just like put it in, right? But yeah, it could break in other scenarios where like you as the programmer know what the string will be, the compiler maybe doesn't have access to it, and stuff like that. But yeah, anyways, I have to say, I do not like this. Like, every day that passes by, I realize how wise the C development team was. I am joking, of course, but you know, in between truths, in between jokes, the truth takes a peek. Um, this guy probably returns. Okay, so it trims this thing. So it means that it returns to me a whole string, because now I should be the one that owns it, right? Oh shoot! It returns a string slice. Okay, how come? Damn. Okay, Happy Monday that replaces Monday and Tuesday, so this will be a string slice. Oh, this one is a string. Wait, what? Okay, okay, it makes sense in the context of the functions, right? Because trim only needs to return, right? Okay, okay, I guess like return a string size whenever it's possible. Return a string when you're forced to. My shift key is D key to lowercase. This will have to be a string because you cannot give me a string slice to this guy. Okay. Yo, we did it. Next. Modules. Ooh, this is gonna be the imports and all of that, I imagine. Okay. Okay, let's see. Fix the compiler error about calling a private function. Oh, are these classes? Are classes called modules in Rust? Right? Replace generally can't be done without reallocation since it resizes, so it... Yeah. This makes sense. Yeah. So, sausage, private. So I'm imagining I just make it public. Oh shoot, public doesn't exist. Okay, pub. Oh, pub. Pub. Is pub the correct answer? Yay! Okay, yes. Hi, Itachi! Hello! It doesn't really have classes in the C++ sense. What? It's just modules like in all languages which are not C or C++. Okay. So it's just a namespace with functions? This is so funny because it's like trying to tell a caveman like what the modern concepts of society are. Oh my god, wait, give me a second. Wait, someone's calling me? But yeah, it's like trying to explain to a caveman what the modern concepts of, you know, things are. Cause it's like, yeah, you have to talk to me in C++ terms or else I will not understand it. Okay, it's a namespace with functions. Which means like I cannot declare. Can I declare variables here? Like let hs be equal to koala. Can I do that? No. Okay, good Rust. Good Rust. It's a namespace with private or public declarations, which can be types, function, constants. Okay. Perfect. Don't have private, so it's moved. Yes. Yeah, I can see that. I can see that. That's pretty good. This is approved. I like this from Rust. Okay, next one. Modules 2. You can bring module paths into scopes and provide new names for them with the use and as keywords. Okay, give me guys 1 second. 1 second while I respond this call. Seems like they're not answering, so let me let me all right. Perfect. Let's see. Funny how nobody's talking about this programming paradigm. Modular programming. So let's see. Modular programming is a programming paradigm that emphasizes organizing functions of a codebase into independent modules, each providing an aspect of a computer program in its entirety without providing other aspects. A modular interface expresses the elements that are provided. Okay, this seems to be very. This kind of sounds like what it's supposed to be. I don't know. I don't know how else to express it. But wait, okay. There's something I'm not. What are we doing? Why is this? Add the following two use statements after fixing them. Buddy, I fixed it. Look at supported languages under that Wikipedia page. Seen in C++, C Sharp, Dart, Go, Java, Camel, and Python, among others. Yo, is this how Golang is? It seems like it, right? Like Golang modules seem very similar to whatever we're doing here. It's just that Golang made the dumb decision that everything that has a capital letter is public in it. I hate Golang so much in that sense. In the 1980s and 1990s, modular programming, particularly due to the popularity of C++. Yay! Yay! Only supporting modules 30 years or more later. Oh no! Language support. Support module concept include C++, allegedly. Rust. Conspicuous examples of languages that lack support for modules are C, and in their original forms, C++ and Pascal. C and C++ do, however, allow separate compilation and declarative interfaces to be specified using header files, which is commonly considered modularization. Modules were added to Objective-C and to C++ with C++20. Pascal was superseded by Modula. I did not know this. I did not know this. Really? This is crazy. It's party time. What? Modules in C++20. What? It's okay if we use AI overview for this. Like, I don't care. I just want to. What? What? I used to pray for times like this. It seems like those times have arrived. What? What is this? Export module hello world. Import iostream. Export void hello. So then this is the public way of. This is like the TypeScript way of doing things. The Java, yeah. Where you specifically export the things you want. What? This is crazy. What? Yo, we're gonna have to take a look at the modules in C++. This is great. We're happy now. Okay, but yeah, let's start to solve this thing because it says to do add the following two use statements after fixing them. Buddy, I fixed them already. Use self-root spare as spare. But it's saying that I am not using this guy. I am using this guy. Do I have to do this? No. No, because this is like, but like why would I want to do this inside that class? Like what? Is it okay to give hints? I mean, yeah, you can bring module paths into scopes and provide new names for them with the use and ask keywords. That is exactly what I'm doing. So what am I supposed to do? Cannot find valid fruit in module delicious snacks. Oh. Is this what they intended me to do? Yeah, and then I do pub use something? Pub use? Ah. Okay. Yeah. Dumb exercise next. Wait, it was not a dumb exercise. Let's see. You can use the use keyword to bring module paths from modules from anywhere, and especially from the standard library into your scope. Bring system time and Unix epoch from the STD time module into your scope. Bonus style points if you can do it with only one line. Use this guy. Okay, so imagine that we can just do use, and then this is like C++ kind of. Right, where we could do use STD time or like go. Oh shoot. Oh, never mind. As asterisk. Some Python mixed in there. Do I make it public? Pub use? No. Okay, I think we need to change fruits to. Oh, delicious fruits pair. Wait, I think this is the correct one, right? Using it in the same module. Yeah, I was just like guessing what to do because like STD time is what seems to make sense to me, right? Because then I can just do like STD time and then do this guy and the same for this other guy, right? But they're telling me that I should be able to use a single line in order to do this. And so what I'm trying to understand is sort of making some sort of something like Python where you like use everything from this guy. So use STD time as maybe the global namespace of some sort, like the children in the use. Oh, use time, system time. Ah. But then they're making me like and comma STD time Unix epoch. Maybe it's and an or dash. No. Okay. Let's see. How to. I'm gonna call it import modules in Rust. Somebody's gonna come and say, well, it's actually not an import, it's a use, but you get the point. Function mount, use cat, yes. Cat dog, cat meow. What about different files? Mod cat. What about directories? Pub mod kitten. Yes, mod pub use kitten meow. Mod use the collections. Okay, perfect, Andrew. Thank you very much. Let's see. So can we take a look at that? Okay. Use the I want to see an example. Use. Oh. That is very interesting. So we just use the brackets for it. Okay, so if I do something like this, where I'm able to say time, and then I pass in system time, and the Unix epoch, oh shoot, and the Unix epoch, then I should be completely fine. Oh shoot, no, it doesn't work. Did I miss something? Option, oh yes, I missed the colon. Yo, let's go. We're experts in modules now. Great. If you're good enough with PEG grammar, you can figure out how to write multi-import from your syntax block. I am not very good at this guy. Not very good, unfortunately. But yeah. ZM! Yo! Hey, did you manage to finish the allocator? Yes! We finished the allocator actually a while ago. Like, I'm willing to say 2.5 weeks ago. I finished the allocator. It was very fun. We went face to face with Malok. We actually were like a little faster than Malok sometimes. Malok would beat us sometimes too. But yeah, we are like basically same performance, which is great for our first attempt. Hey, that's super cool. Congrats on yo! Thank you, ZM. You're like DOG. For everybody in the chat that doesn't know, ZM was the literal first person that ever appeared on on this channel. He was the first chatter, and he was there since the beginning of the memory allocator. I don't know why ZM doesn't have VIP. Let's provide VIP to ZM. ZM VPC. Don't worry, it doesn't do anything because it's like I'm not a Twitch affiliate. It just puts like a little diamond on the name. So yeah, we're a poor household here, but like, you know, it's let's go. But I think our VIPs are Andrew for Joy of Cryptography, ZM because it's ZM, Negvorsa because Negvorsa would tune in all the time, very cool, and Sir Elfman for fixing the problem with my laptop. But yeah. Alright, it's a way to describe grammar of different languages which is commonly used. Useful when writing parsers. Pretty good. Let's take a look. Let's see. What is this? It says hash maps. I got a diamond. Thanks. Yo, let's go. Yeah, you have a diamond now in your name. So, like, there's, yeah. That's basically all it does. Like, I wish it did a little bit more, but it's just like a little diamond. But yeah. Yoo-hoo. Anyways, but yeah, welcome ZM. So currently we're learning Rust because we've been, we've been like learning cryptography, reading this one book that Andrew gave us. But yeah, really congrats on the allocator. It's not a simple project to tackle first, and it's honestly sick you get such good performance out of it. Yo, thank you, ZM. But yeah, it is like one of the projects I'm very proud of. Because, like, you know, we saw the development of it, and, like, we all were like, oh, let's look at the memory allocator. Crypto is great, yes. So we're taking a look at cryptography, and we're going to learn all about cryptography. Today was the last day. We read the last chapter that we needed. So we read all about asymmetric and symmetric key cryptography. It was very cool, very good. And yeah. So now we're doing sort of learning Rust with Rustlings, and that's turning out, you know, there are some little things that we're sort of debating here whether or not they were good decisions on the Rust language side, but yeah, we're just learning the new language. So let's see. Since a basket of fruits in the form of a hash map needs to be defined, the key represents the name of the fruit, and the value represents how many of that particular fruit is in the basket. You have to put at least 3 different types of fruits. And the total count of all fruits should be at least 5. Okay, let's figure out, let's imagine what would the syntax of a hash map be? Okay? For some reason, they don't provide macro for initializing hash map. Yeah. Let's not do that. That is. Wait, what? They don't? So they have vec, but they don't have hashmap? 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 What? Okay. What I imagine it is, it's something like this. Hashmap string u32, and then I'm able to initialize it by putting brackets around it. Shoot. Okay. Seems like that's not the case. I pass it as a parameter while I put : u. Oh shoot, that's not how it works. Okay. Oh no. What is the C++ alternative of this type? The unordered map. If I remember correctly. Yeah, the unordered map. But okay, so how do I initialize this guy? Can I just put in my little fruits here or something like that? Seems like I cannot. Okay, maybe the way you do it, it's like you do. I know I'm rage baiting all of you because, right? I'm trying to watch stuff and y'all maybe like, oh, that's not the syntax. That's not the syntax. But don't worry. Maybe like this. Oh shoot. No. Okay. Okay. Hash maps. Dude, okay, Rustbook. The Rustbook hash map. Creating a new hash map. Okay. Hash map new. Okay. There's no built-in macro to construct them, for example. What? Access values in a hash map. You fell right into my trap. It's actually flat map. What? Brother, what? Flat map was introduced to C++ 23, buddy, what? Oh no. Wait, what? So it's flat map. So imagine compared to an order map. So an order map has the requirement to keep the pointers to the data valid no matter what. Flat map doesn't, right? Open addressing. Okay. I see. That's interesting. Pretty good. But this deters us from the fact that Rust is. See, okay. I hate this. Rust, why are you like this? Wait, is it really just not possible? Wait, but also, I tried doing new, but it wouldn't let me. Tried doing that, and it wouldn't let me. Yeah, so what's oh, because oh my god, I'm stupid. Oh wait, it still doesn't let me. What? So do I declare it here? Okay. That's weird. Yes, sadly, specification. Oh, wait. Whoa, let's see. An ordered map. An ordered map. Yeah, yes. Oh, by the way, how was the internship? Weren't you starting one? Yes, yes. The internship was good. The internship was good. Um, it went well. It gave me like a, it was a little depressing to have to prompt Claude all day. I don't like it, but I'm glad I get time to focus on things like these. It went fine overall. Yeah. They act the same but have a different structure, it seems? Yeah. I might have. Wait, give me a second. I might have what? Wait, I need to. The scroll is not letting me scroll to that. Oh, I might have misremembered. Been a moment. Oh, no, no, no. Yeah, exactly. You guessed it right. Different trade offs looks like. Yeah, yep. Sadly, specification of an ordered map is done in a way where it's impossible to implement it in a fast way. Yeah, it's because it needs to keep the pointers to data alive, right? Can you elaborate on what you mean by fast way? I mean, because there are many alternatives, right? Like you also have the Robinhood approach to hash maps. Then you have the Swiss stable by Google. And there's so many things that are just not possible. Yeah, allows you to store values near each other. Yeah. With the specification of you need to keep the pointers alive. Anyways. But yeah. Let's see. So one thing that I see, it's like, okay, another rant about Rust. So why do we not have a macro to initialize hash map? That's one thing. And that is not consistent at all. It's like, what are we doing? Huh? Right? Like, how? Why are we? Right? Like, why is there no macro? Do you want macros for everything or no macros? Like, Rust, please make up your mind. Please make up your mind, Rust. Okay, I guess it would depend on how often you do lookups and insertions then. Unordered maps have all one lookup, so a flat map does a binary search. It doesn't necessarily. I don't think that's necessarily private, right? You still keep the advantages of a normal map, right? Rust has macro, and I think there's a static map initializer created somewhere. Oh, I see. Wait, but like the Rust book just told us very meanly that they don't care about hash map and that they will not have support. Wait, where is it? Wait, I just saw it. We were just reading it. What? Create a new hash map. There you go. Yeah, there's no built-in macro to construct them, for example. Hash maps also have less support from the standard library. They just hate the hash maps. It's not an STD. Rust's macros are kind of super duper complicated. Like, this doesn't make sense. Why are we doing this? Brother, no. Like, this is... Oh my god. Okay. Packages contain crates, yeah. Okay, yeah, but there's a crate for that probably. Crates are packages, basically. So you can download with Rust package. I agree. But when we start requiring, like, packages for stuff like this, it feels to me like a very bad sign. Like a very bad thing. Because, like, then you start entering package manager hell, where everybody just installs 700 crates without even realizing what it is that they're installing, and now their binary is suddenly 700 megabytes instead of 1 kilobyte. Like, and that sort of pisses me off, but yeah. Anyways. It is still a hash map, it's just open addressing one. Yeah. Yeah, the Swiss tables. Yay. Perfect. So, I guess we're just gonna have to comfort ourselves with using insert all the time. I'm sorry, guys. From, and then let's create a little orange. Put some orange in the basket. And how many oranges do we want? I want 10 oranges. Basket insert. String from. And let's do a guayaba and put 45 up there. There you go. And I hate this syntax, so we're gonna do it. Perfecto. Yay. Yay. Alright, hash maps 2. We're collecting different fruits to make a delicious fruit cake. For this, we have a basket, which will represent in the form of a hash map. The key represents the name of each fruit we collect, and the value represents how many of that particular fruit we have collected. 3 types of fruits: apple, mango, and lychee. Lychee? What is that fruit? What? I have never seen this guy. Who is this? What? Pronunciation? Lychee. 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 Okay. Lychee. Lychee. So we have lychee. We have 5 lychees. That's interesting. I had no idea this fruit existed. There is hashmap from which accepts lists of keys and values. Oh, hashmap from. Okay. Lychee is good, so I highly recommend. Okay, we have ZM as a lychee warrior, so we'll see. You must add fruit to the basket so that there is at least 1 of each kind and more than 11 in total. Okay. We have a lot of mouths to feed. You're not allowed to insert any more of the fruits that are already in the basket. Okay. Okay, so I'm not allowed to do that. Wait, what? You're not allowed to insert any more. Oh, okay. Yeah. Insert new fruits if they're not already present in the basket. Now that you're not allowed to put any type of fruit that's already present. Okay. So imagine, let's try to imagine what the syntax would be. If we're able to crack it open without looking at the Rust book, it means it's great syntax. So the basket is that guy. Basket dot contains key. Oh my god, this is great syntax. Fruit. Oh shoot. What happened? Oh, of course. Of course. We need to barrel the berry because the barrel checker is gonna be angry at us when we don't. If this guy does not contain the key, then we're going to push it. So how do? We do it insert the fruit that we're talking about, and the value that we want is 56. Great. I did not borrow this value, so if I use it after, I imagine the compiler is going to cry. Right, so we do println little guy, and then fruit. This will not be allowed. Oh, shoot. Okay. Oh no. I don't know how to do this. Okay, that's fine. Pretty sure they have method to do it in 1 line. Actually, yeah, wait, let's see. Insertive, something like that. No. Dot. Enter, drain, into keys, into values. Keys, values, contains key. Get key value, get mute, hasher. Remove entry, retain. Shrink to, try and reserve. The entry API. Okay, I don't see entry here. Oh wait, I just saw it. Entry. That is bad syntax. What? Okay, yeah, I do not like the fact that there is a guy called entry. I, I don't like that fact. You know, love it, love it, whether you agree or don't. I do have to say, I don't like that. Because you get rid. Oh, wait, what? Body. Okay, what do you accept? Entry. Only a single key. What? What? How to insert in Rust hash map only. Wait, actually, I think the book. There you go. There you go. Only the keys in present. Entry, yeah. Oh, dot or insert. Oh, okay. Okay. Never mind. I feel that's kind of cool, but I still don't like it. Or insert 56. Okay, but I still feel I don't like it. I feel like you get rid of the beautiful explicitness of this statement. Right? Penguin operator. Good night. Yeah. But this statement, like, this is beautiful. Like, I know exactly what's going on here. If the basket does not contain the fruit, insert it. I feel like you get rid of that when you do something like this. I don't know. I don't know. I don't know. Maybe it's just a matter of coding styles, but I don't know. Let's see. Hash maps 3. Let's see. A list of scores, one per line, of a soccer match is given. Each line is of the form team 1 name, team 2 name, team 1 goals, team 2 goals. Examples. England, France 4-2. You have to build a scores table containing the name of the team, the total number of goals the team scored, and the total number of goals the team conceded. A structure to store the goal details of a team is here. Okay. The above can read get entry at fruit or insert 56. Yes, but like, you know, there's like, I feel like it's not explicit enough for my taste. Of course, like, I will get used to it, right? But there are some things that, like, I don't know, it just seems like it's not very explicit for me, but you're right. Let's see, populate the scores table with the extracted details. Keep in mind that goals scored by team 1 will be the number of goals conceded by team 2. Similarly, goals scored, yeah. So I imagine we can just do scores, right? Scores dot insert. Actually, no, we cannot insert, right? Because multiple teams may be fighting each other. So then we just do scores dot. Let's do it the idiomatic way. I will not code like this. I feel, but it's okay. Team name. We want to learn as much as we can about Rust. Insert entry. So entry dot or insert. And we're gonna insert with what? Insert sort of the empty struct. So that would be team scores. This guy, the empty struct. And then I just put in the values I want, which would be goals scored of 0 and goals conceded of 0. Right? What is the problem, Rust? What is the problem now? Mismatch type found. Mute team scores. What? Yeah. Wait, so what's wrong? Let's see. By the way, you don't have to use the entry API. Somebody in chat mentioned one-liners, so I felt it right to mention the enter. Yeah. No, for sure. That makes sense. That's why I said, like, you know, maybe it's just a matter of coding styles. It's good that it's a possibility. I don't think I'm gonna use it that much, but we'll see. Only time can tell. But now I'm trying to figure out like what the problem here is, right? Because the struct is fine. Consider using a semicolon here. Oh wait, is it because I'm missing a semicolon? Oh, the age-old error. Okay, and I feel we would do the same thing, but for the other guy. Team2 name dot or insert, and then here team scores. And the same, goals conceded 0. Goals. Oh, sorry, goals scored 0. Goals conceded 0. So one thing I'm curious about, and do Rust structs support default values? Something like this. Oh, default values and fields are experimental. See this issue. Oh, I just want to see. Wait, I want to see what the discussion is. I want to see what they're talking about. There's probably like, okay, let's make a bet on the amount of comments that are present in this issue. If you were to guess. So my bet is it's going to be between 18 and 22 comments. Okay. Unresolved questions. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No! Okay. Oh no. Got 120 remaining items. Where? What? What do you mean 120 remaining items? Huh? Also, like, the amount of issues is insane. Anyways. Dude, this is such a titanic task. Like, oh, just search 120? That is a great... Oh my god! Never mind! Never mind. Oh, I guess this we're way off. Way off. Oh my god. Dude, what? Damn. Pretty insane. Did pay your respects to the people that design your languages, because like they care so much, and that's good. But like, imagine caring so much and then committing the worst crimes against syntax ever in humanity with some of the decisions of Rust. I don't know. But yeah, this is very cool to see the process. Anyways, so these are experimental, so let's not use them. Okay, so instead we're gonna have to do this guy, and then every single time we would be able to just say, by team2 will be the numbers. Yeah, so then we can say scores dot, or like, can I index by key? Like this. Team1 name. And then I need to borrow it, of course. Oh, wait. When I provided this guy, right, I didn't... I need to borrow it so that it stays alive, right? And then, can I use it here? Dot goals conceded, goals scored, is equal to... And then, I don't know. Well, plus equal the team 1 score. Cannot assign to data in an index. Okay, yeah, and so this is... Oh my god, okay. I forgot what it's... I hate that pattern. They got this from JavaScript. You can just put a... If you're returning result or option, makes it somewhat smoother. Wait, what? This guy? Wait, no, because what I imagine is it's like the problem with the Swiss table, right? That you cannot really... Like, the same with Go, right? In Go, you have to, like, reinsert the entire thing every time, which is kind of annoying. But only in a function that returns a result type. Wait, but, like... Yeah, this guy is kind of, anyways. But, okay, here, right? They're telling me, like, you cannot modify it. So I imagine I can just do something else. Right, something like... Okay, what can we do? Can we do scores.getMutable? And then I pass in the key that I'm talking about, which is team1. And then I say mismatch types, expected the unit type, found the enum, of course, because this is not close. Then I say dot. Brother, I was trying to get the mutable. How can I... What? Okay, what is this? This is an option. So imagine I just do this. Then I do dot. Okay, so I can also do dot unwrap. And in the process bring down all of Cloudflare. Then I do goal scored. And then I can say plus equal. Right? And then team1 score. Ah! Pretty good. Pretty good. Ouch. What do you mean reinsert all the time? Like, you wouldn't be able to change the value inside a map, if I remember correctly. Something like that. But like, it's been a while since I've coded in Go, so let me know if this is not the case and I'm just inventing things. But it's like, you're not allowed to change. Actually, wait, I don't remember. I think it was something like, yes, you cannot modify the thing inside the map. Something like scores at this guy, team1 name, dot goal scored, right? Like goals conceded equals 10. You cannot do. You need to create another object and then sort of insert that object in that new position. Although I like take that with a huge grain of salt, because it's, you know, absolutely like, this is just like so vague memory I have. So it's probably, you can modify it. Last time I read anything about Go, I heard they did not have generics, and apparently they added them since then. So maybe whatever it is with mutability of map fields was also changed if you want. That's not true, bro. You can mutate destruct if you want. Okay, I see. What was the thing that I remember? What is it then that I'm remembering? Because I do remember being like, whenever I would see a map in Go, I would panic. I would be like, I hate this thing with all of my soul. You should read a book on it. I mean, I'm not sure if I would go as far as to read a book. Like, but yeah, wait. Mutate map entries in Golang. What was it? But after that, it depends how you store the object. Brother, what are you talking about, Arctic? Arctic is... Okay. Yes, exactly. That's what I was talking about. That's what I was talking about. You cannot modify, yes, the elements inside a map because of... Yes, yes. Okay, okay. Oh my god, Arctic, of course, yes, but like... Bro. Yes, yes, wait, this is what I was talking about. This is what I was talking about. Okay. Yeah, exactly. That's what I was talking about. That you cannot do that. You cannot do this. Right? That in Go, you need to reassign the value. Of course, if you insert it as a pointer, like you're going to be able to, right? But like if you don't, which is like, because then you also have to worry about where to store the things, right? Like sometimes, right, things like these are like, okay, all right, great. Oh my god, is this the same? Wait. Oh no no no, it's not the same. Okay okay okay, good. So okay. So yeah, that's what I meant. That's what I meant. Um, problem solved. Please don't scream like that. Your micro is maxing out. Oh my god, I'm so sorry. Wee wee. Okay, let's. Is that better? I think that that reduces better. That's not myself. Yeah, I agree, Zian. Wait, no. I mean, I like why. I remember at some point in time being like, oh, because of this decision, it makes sense. But I don't remember what it was. Which is an interesting thing, right? Like, why can't fields of structs be modified in a mapping form? Can we take a look? I have a map of int to struct. Why can't I directly modify that field in a map value? Yeah, there you go. You're storing a struct by value, which means the accession of the struct in the map gives you a copy of the value. This is why when you modify it, the struct in the map remains unmutated until you override it with a new copy. As Ricky pointed out in the comments, you can store the pointer to struct until... Yes, but like... Why did the designers of Go choose not to allow direct... Yes, exactly. Safety during parallelism. When you're adding elements to a hash, the language often has to copy all the values to a new, bigger hash table in the background. If elements can be directly modified in memory, it will be impossible to keep all the copies in sync. If all update operations are forced through here is a new value, then it's easy to make sure both copies get updated. Without this, copying a hash would be a stop-the-world operation. But, I mean, okay, I guess, but... Yeah, because then people find, like, sort of the workarounds around that, which I don't find very appealing. But anyways, yeah, it's a little weird, and that's why every time I would see a map, I'd be like, oh no. But yeah. Hello, Best Creeper 21. They use Swiss tables, yes, I know. It probably makes it faster in Rust's map or C++'s. Yeah, the whole point of Go is concurrency when using routines. Yeah, I remember Rust being marketed with fearless concurrency or something, and it has mutable map entries, I think. I have a 50k project in Go. I ported it over from C++ because it just makes parallelism, networking, and cryptography much more straightforward. That's good. If you want to compare default fields discussion. Oh, wait, let's take a look at how Zig compared these things. Which is interesting. In Zig, this is issue number 485 versus issue like 132,400 something. Yes, this looks ugly. Blah, 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 blah. Oh, wow. Okay, it seems like the Zig people are able to coordinate better. Um, yeah, this guy is only celebrating. Oh, sorry. This guy is celebrating. He is putting his arms in the air. Yo! Yeah, it seems like Zig had a way better discussion. Let's see. Perhaps it's limited in concurrent situations, but otherwise, yeah. Plus, Impotums are much better. I would rather use Zig than Rust. I like their philosophy. Seems like a much more minimalistic language and fit for systems programming. Like, what's the point of the barrel checker when other languages like C++ already have tools to do pretty much the exact same thing? There's literally a flag for bounce checks and other things. Well, okay, yeah, maybe I don't have much experience to answer the question. I feel there would be like there has to be a reason, right? Like, because if such a thing were to be true, you wouldn't have like all of the buffer underflow and overflow problems that you would have in, you know, like in the wild world. Because if the tools already exist, or is it just blamed on the fact that people are lazy? I don't know. Let's see. Get mute, and then get team1 name dot unwrap, and then goals conceded would be team2 score. Then I duplicate these lines because they're very good friends. How do I duplicate a line? Yeah, there you go. And I do team2, which basically it would be the same as changing the occurrences of team1 with team2 name and changing these two around. Right, so goals scored, this would be team2 score and team1 score. Yay! Perfect. And then we return store. Alright. Awesome. Yay, we finished maps. Yo ho ho. Alright. I see my people are lazy, but Rust just wants to handhold the programmer. Comes with the custom compile types and other stuff too. My entire project compiles in like 100 milliseconds, 50k lines. But then it becomes like I'm not sure if compile times would be a justification to go against Rust in this case, right? Because then running the tools related to C++ having this sort of ability would imply sort of similar compile times, right? So either you're risking insecure and your compile times are really fast, or you're secure and your compile times are slow, right? And I'm not sure. Okay. Okay, it's 5:30 already. We will have to. Oh, wait. Give me a second. There you go. Okay. C++ is insecure and compile times are slow. That's a counterpoint. True. And it's just because of LLVM, I feel like in the language complexity. I see. Okay. Yeah, not as slow as Rust though. Alright, perfect. Yay. Oh, another map mention. Okay, perfect. Now we have options. So I think in answer I need to take a look at some messages here because they're important. Oh, let's go. Alright. So we're gonna have to work with options. I am not sure if I am made for this because oh my god, look at all of the things we have left. Okay. Let's see. This function returns how much ice cream there is left in the fridge. If it's before 2200, 24-hour system, then 5 scoops are left. At 2200, someone eats it all. So no ice cream is left. Return none if hour of day is higher than 23. Okay. Yay. Let's see. If so hour of day. If it's before 22, so if hour of day is smaller than 22, then we want to return the 5 scoops. Oh my, what? Else, and then we. What is the problem? Mismatch types, enum, option, found type, integer. Oh, what is this? Okay, so I imagine I have to do option, and then what? Then like 5. Option dot. Option sum. Okay, so it's very similar to a camel 2 in this case. Okay. So then we, hour of day 22, at 22, someone eats it all. So no ice cream is left. Return none if hour of day is higher than 23. This is a very confusing spec. Because like, okay, let's see. Else if hour of day equals 22 or it equals 23, then I return 0, right? Otherwise I return option none. Right, this is the spec. Maybe ice cream at 12. If hour of day is smaller than 12, return option sum for 12. What? Found type integer. Fix this test. Oh, okay. Okay. That makes sense. So maybe ice cream 12, and then I just do sum 5. Oh, don't change this line. Okay, so then I imagine I do unwrap. Yes, okay. Yay! I think this is what the spec means, no? If it's before 22, then 5 scoops are left. At 22, someone eats it all. So no ice cream is left. At 22, And then return none if hour of day is higher than 23. So that can only be like, yeah, so the hour of day, yeah. Seems to be, I don't know. Let's see, let's take a look. Ooh, the chat seems to be, let's see, I like Rust. Yo, let's go see him. Problem with C++ and templates is what each time you use hash include vector, entire vector is compiled from scratch for all of your compilation units, even if you use it for same template types. Linker later deduplicates duplicate instantiations. Modules should theoretically solve it. We lost you to the big Rust, Aaron. Gilly! Don't worry. I'm not the biggest Rust fan. I am feeling a little neutral towards Rust right now, so I don't think you've lost me. That's why competent C++ programmers don't rely on the STL or the CRT and avoid including big headers that include declarations the client isn't going to use. Yep. What's wrong with STL? Chat is heating up. True. Rust has them and the compile times are slower, so I don't know about that. I think it's a skill issue. I don't like C++ for various reasons, but you can use it competently. I don't like OO and the generics in C++. Don't like RAII. This is wrong. Template for type T is not recompiled if T is not updated. All right, all right. I'll let you guys discuss. It's like, hmm. Anyways, you get optional experiment. Oh, I think we good. Good. Oh my God, we transitioned to the quiz. What? Oh, I wasn't supposed to go to options. I was supposed to go to the quiz. Okay, let's build a little machine in the form of a function. As input, we're going to give a list of strings and commands. These commands determine what action is going to be applied to the string. It can either be uppercase the string, trim the string, append bar to the string a specified amount of times. The exact form of this will be the input is going to be a vector of two length tuples. The first element is the string, the second one is the command. And the output element is going to be a vector of strings. Okay. Okay. To do, complete the function as described above. To do, what do we need to import to have transformer and scope? Okay, let's complete the function. So it says a little machine in the form of a function. As input, we are going to give it a list of strings and commands. These commands determine what action is going to be applied to the string. It can either be uppercase the string, trim the string, or append bar. The exact form of this will be the input is going to be a vector of two length tuples. The first element is the string, the second one is the command. Great. The output element is going to be a vector of strings, so the results. Okay, this makes sense. So I imagine that we do, let's see, polythene transformer, right? We accept an input, and that input is going to be a vector of multiple tuples. So those tuples are going to be, first you give me a string, and then I give you a string, actually, yeah, and then you give me a command on that string, right? And then this guy is going to have a return type. And that return type is going to be just a vector of strings. Yes. Oh, shoot. What? Oh, okay, yeah. So now what we do is we need to go, okay. So I need to process every string and every command. Can I do something like this? strcmd, and then like in input, something like that? No, okay. Okay, let's figure this out. For loop syntax in Rust. For in range. Yes, yes. Names that eater. Oh, okay, so it's eater. Okay, eater. Oh, what? This borrows each element of the collection through each iteration, thus leaving the collection untouched and available for reuse after the loop. Okay. Input. Okay, so I imagine that what I can do is... Oh, what was it? It was like... Sorry, I forget the name. Eater. Eater. I get it for string cmd in input.eater. Right? Right? Okay, I'm just gonna add return vec string new, because that error is really bugging me out. Yes, okay, perfect. Unused variables. And so now what I can do is we can say, what do we need to do? Let's see. Let's read the chat. I want to see what you guys are saying. Oh no. Okay. C++ is just too overcomplicated, just like Rust. That's why I switched to Go. I already liked C a lot. Templates are only generated when a new type declaration is used, which is identical to Rust's generics. Statement was about cold compiles. Yeah, for hot ones, if dependencies didn't change, you don't need to recompile a compilation unit. Go has garbage collector, which makes it unfortunately unusable in my domain. Oh no. I don't get how my entire Go project on cold run can compile quicker than a C++ cached compile. The linker is too slow. I wish they did the memory management properly. True. GC doesn't mean anything. There are ways to control it or disable it entirely. Because C++ does more optimizations and doesn't rely on parallel runtime. Ooh. We have a streamer on Twitch who tries to use Go without GC by making GC calls panic. Not sure why though. No, there's another Go compiler that doesn't include GC at all. I work in plane manufacturing. What? Oh no, Kili, please don't use Go. Dude, there's one of the things that I like fear the most, and that's airplanes. Every time I go on an airplane, panic immediately. Please, Kili, keep us safe out there. Programming language power scaling competition in chat. Well, if you allocate things on the heap all the time, it's gonna happen one way or another. What? Okay, let's see. I hope you realize, as I just said, there's a version of Go without GC for embedded systems. I'm telling you this because I write firmware for robots. Ooh, pretty cool. I've been writing C for years, so I know everything you're talking about. Go strings are also duplicated on each use. Go's map allocations is consistent to other types. Go's yield cementing creates a virtual allocator. Go's channels copy objects. It's a skill issue? That is not a skill issue. Wait, yeah, it's true. Wait. Well, these are some valid points. Why does Chrome do hundreds of allocations from std string copies, then every time you type a character in the search bar? Wait, but is this a criticism of the language at all? Are you implying that like, oh, it's a fault of the programmer then, rather than the language? Who knows? Right, let's try to figure this out. The exact form of this is irrelevant. Yeah, whose fault is it? Yeah, okay. Yeah, okay, so Arctic was making that point. But wait, can the behaviors that Kelekele described be changed in Go? In our code base, we don't have strings, for example. Damn. References in Go, if you really care. Interesting. But I feel like, both of you have some points. Go is able to support these things, but Kelekele is saying, like, it doesn't seem to be the natural way to do it. And it's not the natural way Go was designed to do it. So, interesting. Let's build a little machine. The exact form of this will be, the input is this. Okay, so it's uppercase, trim, and append. So imagine what we can do is we can actually create a match. Yo, match CMD in this way. Match is my favorite guy. Right, we just do uppercase, and then we return, or we do, right, whatever this guy tells us to do. So if we're going to deal with uppercase, we need to add to our result. So imagine here I can have let result be equal to vec, right? Vec of strings, and then new. There you go. So that's our result. And then we could do result.push or something like that. Yes, result.push. And then I want to push my string just as an uppercase. Right, to uppercase. And to uppercase returns, it returns a string. Okay, so that's good, right? Cannot borrow res is mutable. As is not declared as mutable. Cannot borrow as mutable. What? Pattern byte in uppercase is named the same as one of the variants of the type command. Wait, so what am I supposed to write down here? Okay, I see. Rested push str.uppercase, right? Yeah. Great. And then the next one will be command trim. And with trim, we do a very similar thing where we say, well, to the response, we need to push whatever the string.trim is. It's str. Mismatch types. Expected string found. Okay. So then I just say string from this guy. And then I just return that. Yes. Then finally we do command append. Then we append user, so number of times. And this is just gonna give us rest of, well, for I in none, maybe? Or in like 0 dot dot none. Oh, what? Mismatch types, expected integer found u size. Can I not do this? What? So this is allowed, but the other guy is not allowed. This is not allowed. Okay. Any sort of help that we can provide to this poor soul? Is it the name? Maybe Nui? Nui? No, mismatch types, expected integer found u size. Yeah, what's the problem? What? Wait, what? Brother, no! Okay, let's see. Oh my god, guys, guys. Okay, if you really care, if you really use that specific compiler, if you do this, do that, is not that different from C++. I see, I must be old and go wrong. I'm just saying it's a skill issue because the language doesn't stop you from doing that. It'd be like me saying, oh, Rust doesn't allow you to mutate random memory addresses. Your lack of understanding of C++ is their first. Guys. I feel we have two very confident people here. Like, I mean, both of you know a lot, right? Like, both of you know, like, Arctic surely knows about C++, Killikale knows about Go, and I completely ignore unsafe. And in some cases in embedded, you need to use unsafe. I'm not against Rust at all. I would support it in new projects, but I wouldn't consider Go a serious candidate for anything embedded related. Interesting. Java surpasses Golang on benchmarks. Really? Whoa, I don't believe that one. What? How is that possible? Well, I write firmware and high performance networked applications and make a lot of money using it, so. Okay, this discussion is kind of stupid. Someone's calling the Lulu. Okay, alright, guys. Alright. Relax! Right now! Why are we having this fight? Dude, come on. Hmm? Although it's funny. Please continue. But yeah, no. Don't worry. But yeah, let's see. Mismatch types expected. JVM is insanely optimized with JIT hot paths, so it doesn't indeed surpass Go many benchmarks except for memory. Interesting. I did not know this. Oh, sorry. Give me a second. I need to attend this call. Guys, what are we doing? Please. Dude, I take my eyes off for 5 seconds and then. Oh no. Seems to be true. Andrew says, seems to be true. Java really does surpass Go. Oh, wait, pretty cool. I think this is because Go is specifically made to be compiled fast, so it doesn't do a lot of optimization. Oh, okay, yeah, so there you go. Everybody gets a winning side. Compile times with Go are indeed fast, but then you sacrifice a bunch of stuff because of that. The other guys have a long compile times, but they are able to perform more optimizations. Yeah. And the memory usage surpasses Go too. Arctic, relax, bro. Relax. Don't worry. We're comparing speed now and memory. I can write a Go program that beats that by 100x. Arctic, don't worry. Arctic, please, bro. Okay, guys. Okay, I'll look at the chart. Don't worry. Don't worry. Let's see. What are we fighting over? Let's see. Current mature data was generated on July 2024. Full log can be found here. Okay. Binary trees. Java. Okay, code. Time. Oh my god, okay. Yeah, this is pretty slow. Oh my god, okay, what the fuck? What? Okay, what? Oof. Okay, I feel like I don't see what you guys are fighting for. Because, like, both of you have a reason. Like, Killa is not talking about the memory, he's just talking about the speed. And in speed, Java wins. It seems, right? Arctic is talking about memory, and in memory, Go wins. So, what is the discussion, right? Like, it's fine, right? Like, I do have to say, I am very surprised that Java is faster. Because in my mind, it has always been like, Java is really slow, Java is like, ba 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 ba. So I'm very surprised to see this, but I mean, it's great, right? If in the end it like ends up winning, that's great. So, pretty good. The Coral Prime C, for example, has timeout. Okay, well, yeah, Go timed out on this one. Unfortunate. Let's take a look at what it actually is that they're. A concurrent prime sieve from Go's official example. Ooh, that adds a little bit more weight. Okay, Java. Okay, I am so sorry, guys. I know some of you love Java. I personally cannot stare at Java code. I yeah. Okay, I mean, I feel this is a very silly discussion. Like, in the end, both languages seem to be very performant. You should use the one that you're more familiar with and the one that actually serves the purpose that you're trying to fit. I feel like in the same way you can say like, oh, Go can be adapted to do this and this and this and this. I feel the same could be with C++, right? You could just say, oh, C++, please don't perform any optimizations, and then you could have the speed of the compile times be faster. So, I don't know. Let's see. If we're short on memory, why are we even using a GC language? The Go file is written by a novice like one of these guys. I just said Go is lower than Java, and this guy's fuming. tinygo.org. Ooh, I love the Gopher. The Gopher is like one of the best decisions they could have made for the Go language. He's so cute. Okay. I can write some intrinsics to use SymD and Go and getting. Plus, I wasn't even talking about speech recognition. Guys, Dude, what even is this discussion? What even is this discussion, bro? Okay, I'm not gonna read it anymore. I'm not gonna read it. Let's see. Come on, append. Numi. What is okay? For loop in Rust. How to use a reference in. How can I? Yeah, in for loop iterator. No, no. No, I don't need this. I want. So the problem I'm currently having is this guy, right? Append Numi, and then I just want to create a for loop that does, Numi many iterations. But it says uses is not an iterator. Required for users to implement into iterator. Yeah. So if I do this guy, if I do a range, then it's gonna tell me I expected an integer, not this guy. Rust range with ampersand int. No, I'm looking exactly for this guy. Yeah, because how am I? What? Okay, guys, does anybody know what we're doing? Like how? Oh, you need a number, but you got a reference. Need to. Okay. So I see. So this should work. I see. Okay, so I should think as references like exactly as in C++ pointers. Um, they're not just like a borrow checker construct. They are quite literally pointers. Well, they're not pointers because they're not pointing to anything in like. Whoa! That's not what I'm saying. They're not pointers because they're not addresses in memory, but like the feeling is the same. Okay, yeah. Okay. Um, but yeah. Let's see. In 2022, I was suggesting Go for a microservice in the company, and my hands was beating for it. So I was actually Go advocate. Wait, look, see, this is the good ending. Like, dude, you have to realize that, like, sometimes like you guys are fighting for things, but like you agree in more things. Actually, like, I feel that you guys are agreeing on like the fundamental stuff. It's just that like, one loves this language more, the other one loves a different language more, and like the languages are comparable. They can run at basically the same speed if you perform the right optimizations. Anyways, if it can't for okay, thank you, Andrew. Who cares? Arctic, bro. Tell me, Python is better than Go, cause Go has a gopher as a mascot, and Python. This is what this discussion has been reduced to. So I know all the ins and outs of Go. Sure, buddy, sure. You're the hello world, HTTP server. Okay, Arctic, we don't know. Okay, we don't know what Kalekale has done in Go. It's very likely, actually, given that it works on planes, right? It's probably looked at some things in Go. They are addresses in memory plus Rust's guarantees about uniqueness or immutability. Interesting. So they are pointers. They are just have a special status from the perspective of the borrow checker and the mutability and all that stuff and the compiler in general. I see. Okay, he talked about garbage collector, but how come the memory use is just lower and compile times are much faster? Wait, but okay. I feel that like Kalikali brought up Java, not as in you should use Java before Go, but as to say like Java is faster than Go. He never mentioned memory and said like memory is really bad in Java. But like if we're talking about speed, Java is good. Because Kalikali was not advocating for Java originally. He was saying like, oh, C++ is what I use. He was not saying let's use Java to make airplanes. So the garbage collection, I think, came from the side of C++, and then he used Java for the speed. I'm not a language fanatic. I use Go, C++, Python. And the same use of going in a performance critical space is not a good idea. I see, but I feel that's also a very radical point, right? Because I am very aware of like many projects that use Go in like embedded systems and everything, and it's like the core of the project. Plus, Go was designed like well, all parallelism, sure, but also for it to be used in embedded systems. It's used all over the place. What are you going to do to change? This is a strawman argument. I bet it could outpace going in small talk. Yeah, you can cast them to a regular pointer, no problem. It's even safe to do. Really? Oh, let's go! Yay! Because I imagine the compiler helps you with that. I see. Me too. I use a ton of languages. I know probably 20 different languages. The example is badly written. I just read it. Okay. Oh shoot! Wait, why did I pin this? Ah, sorry. Unpin this message. I was just clicking. Okay, perfect. Thank you, Andrew. So this makes sense. And so for each and every single one of them, what we're going to do is we're going to say, ooh. So what do we do here? I think we can just have at the beginning. We can have. Oh, sorry. Let sort of like str modified be equal to string from whatever you passed me, which is going to be the string, which is a slice, right? Oh no, it's not a slice. Okay, so I no longer need to borrow this guy. I need to actually modify it. So imagine I can do the clone. Yes, and then strmod plus equal, then a plus equal bar. Cannot borrow strmod as mutable, as it is not declared as mutable. Oh, that's true, my bad. The mutable. And then here what we do is we say result, please push in the strmod line. Yo, perfect. I is not used. Okay, what am I supposed to do? Underscore? Okay, pretty good. Yo, excellent. So once the match is finished, once the for is finished, I return not this, but result. Ooh, cannot bar rest is mutable. Oh, of course, mutable. Perfect, yay. And then instead of output, cannot find function transformer. Oh, what do we need to import? Okay, yes, we do command, and then we put colon, and then oh shoot. Oh wait, no. Use, sorry. Use super to oh shoot, what? Oh, it's my module. Wait, what? Use super, my module, transform. Yo! We passed the quiz. Let's go. Awesome. Great. We also solved options 1 exercise. Let's finish options, and I think we're gonna stop there once we finish options. Because it's been a while, like it's been a long time. Let's see, simple option, rustlings. Okay, make this an if-let statement whose value is sum. What the hell is an if-let statement? If-let statement in Rust. For some use cases, when matching enums, match is awkward. For example, this guy. Okay, yes. Okay, if let sum I equals number. The if let construct reads, if let destructures number into sum I, evaluate the block this. Interesting. Okay, okay. It's. I mean, I feel that it's something I feel good about. Let's see. Make this an if-let statement whose value is sum. So this is borrowing from functional programming. Let's see. If let t is equal, well, sum t, right, is equal to optional target. What? Make this an if-let statement whose value is sum. What? I feel like I had it correctly, If let sum t is equal to this, I need to wrap this up. And then what I need to return is, I'm not understanding what they want me to do. Right? Like, what am I, am I supposed to do like if let sum and then I put in word equals optional target? Like, I don't know if that's what they want me to do. It's okay though. Adds another layer of option. I don't think so, because then here they're having the same syntax. Oh, maybe they want me to complete it like if let and then some integer. Is that what they wanted me to do? What? Mismatch types expected enum option I8 found type. What is an I8? An integer is an option I8. What? Pop returns an option T. And so when I decompose it, it should be able to. Okay, let me read the chat while we try to clarify that. Let's see. The example, I'm not going to respond anymore. Chay, se eu falar em português aqui no chat, você entende. Buzztronic. Not sure what that guy means. You can also write it as command append. Okay, this will pattern match by reference and give you value back. There is ampersand in there if you didn't notice. Oh. Wait, that's interesting. Oh, so does pop return a reference? No. I think, I fear you may be talking about one of the previous ones and I just didn't see the message in time. Sure about that. You can also use clone frequently as long as you are not abusing. Return value optimization does wonders there. Pretty good. C++ for 10 plus years, go for 5 years, made a lot of money. Dude, Arctic, why are we so aggressive? Dude, no, don't do that. If let, and then if opt dot has value. Yes, but they want me to use like the if let, they want me to do this. Make this a while let statement. Oh, never mind. They want me to make it a while let statement. Remember that vecpop adds another layer of option. You can do nested pattern matching in if let and while let statements. What? Okay, I'm sorry guys, I'm not understanding. Optional integers. It's a vector of options. So when I pop it, it gives me an option. And so, oh my god. What? Okay. While let some integer equals to this. Right? Right? then this guy. So what do I have to do? Is equal to. So they want me to nest them. So I could just do if let some res equals this. Right? There's nothing stopping me from doing this. It seems like there is. And then I just nest it and I put res. Ah, never mind. Okay. Because you can do nested pattern matching. Oh, wait. I think I know what they mean. They mean something like this, right? Yes. Okay. I was about to cry out to the skies if whatever I was writing was possible. Because it seemed really silly. Okay. No, it's about last task. Oh, what? Oh, about last task. Okay, so this guy? Oh no, it must have been this guy. Oh, the quiz. Yes. The Numi guy, right? I imagine. Yeah, so if I just do this, Andrew tells us, we can just pattern match. Oh, shoot. Expected type usize found reference this. Mismatch types found usize. What? Consider removing. What? Okay, I'm not sure why it isn't working. It's okay. I'll read your explanation Andrew, if you have one. Pop removes the object from a map, so I'm pretty sure it can just return it with full ownership. But it has to return it wrapped in an option in case the key isn't there. Okay, I see. I still don't pop vector image rating out of habit. I was burned enough. Oh my god, a wall of text by Arctic. Oh no, let's see. I refuse to believe Rust compiler can handle that. I don't really like optimizing compilers anyway. I'd rather have my fast compile times than write optimized routines. What? Code gen, so that's why it's pointless. Own data structures as well. Okay, wait, this discussion is a little bit stupid. Like, if you want to make the language fast, you can do it independent of whether or not you're using Go or C++. So both of you should be very happy right now. Like, yeah, let's keep the discussion there. Like, it's like the Odyssey taking place right before our eyes. But yeah, all right, option 3. That's what I'm saying. Okay, that's good then. Let's see. Optional point. All right. Let optional point be this guy. Fix the compiler error by adding something to this match statement. Something? Like, what am I? Okay, let's see. What is the compiler error? Borrow of partially moved value. Optional point. Partial move occurs because value has type point. Okay, so in this sum, I think I'll be able to borrow it. No. Okay. Here, I should be able to borrow it. No. Okay. So, oh wait, no. The problem is optional point. So maybe it's match. Yeah. Very interesting. Very interesting. Yay, we did it. All right. Oof, I think we can stop here with the rustlings thing because it's like, you know, it's taking a while. It's taking some time. So, because we've been here for like 2 hours, just looking at rustlings. I just don't want the language to get too much in my way or be interpreted. But I hate when people make false statements with Wait, Calically was not saying false statements. Like, maybe there, maybe there's some imprecise things, but like I feel you guys were doing it like at the same level, no? Like, don't worry. Addison Compotos though has a few thousand lines around my own hash maps. Sure, but like, yeah, don't worry, Arctic. Relax. Okay, I'm going to. All right, so we have finished the Rust section for today. Well, not finished it, right? But like, it's there. Ah! Okay. You kind of lost the plot. Yeah, don't worry. I think it's just that like the discussion was a little heated. Right? We'll just need to calm down. Let's calm down. Realize that we are all actually in the, we all have good points. Like everyone can use the language they want because they can optimize it for it to be really fast and very low memory consuming. But yeah, he said he worked on airplanes. Yeah, but I think he used it to show that like it's very critical code. But I haven't responded to you for the past 2 minutes. guys. I don't whatever you're gonna do. Alright. No, Kilik, do not filter your data online. Do not give your Gearbus employee ID online. Bro, I can show you my. Guys. Okay, relax. Guys. Oh, sorry, Andrew. Sorry. This is like I'm saying like, brother, what's going on? But yeah, crypto. Guys, relax. Okay. We're gonna have to. Okay. So what else can we do for crypto trust? No, the fact that somebody's a crypto bro is not. It's not an argument to reject their opinion, but like no. Okay. I think we're all missing the point here. Don't worry. Like, look at the stream title Archibald. Okay, guys. Relax. Oh my god. Okay, I'm gonna have to time you. I'm gonna have to time you guys out. Like, I want you to be. Dude, okay. Like, relax, okay? There's no more need to continue the discussion because we've already reached a point of solution. Alright? Okay. Yeah, relax. Okay. I think we all have, like, it was just a heated discussion, which, it's usual when you have, like, passion for your things. But, yeah. So, I think, like, wrestling's is fine. It's just, like, it's a little bit, annoying to have to go through, like, 23 of these things. I guess it's necessary to learn about the language, but, be entertaining if it didn't. One of the things I do remember, I didn't really check. Kale. Okay, nobody answered to anything that's in the chat. We've left the discussion behind. Whatever, dude. Okay, yes, that is okay. Good response. You hater, go for it. All right, I just want to read the chat for now. For loops in Rust. Why is this guy? Oh, okay, it's an Android guy. All right. So one of the things I think we, let me think. So we have finished Joy of Cryptography, which is excellent. Right? We haven't finished the entire book, but like we have the basic stuff. We're learning Rustlinks, and now we need to proceed to. We could continue just doing, other stuff, but I think it's a good thing to. Because I'm not sure I'm ready to start coding the cryptography part. because I don't think I have enough language, enough knowledge of Rust. Um, so yeah, so that's gonna be something I prefer to replace. One thing I'm interested in is async, right? Like how how bad is async in Rust? Because we're gonna have to, yeah. Async is nice to use as a consumer of basic APIs, but my few attempts at creating async libraries have not been fun. Hmm. You have to use many levels of wrapping around things in order to do type erasure. In my last attempt at making an async library, I ended up with such a convoluted mess that I just gave up on it. There were so many layers and hack types that only existed to make. Oh my god! Oh no! Oh no! It's quite a bit of debate about async versus threads. Hmm. Okay. Because one of the things I'm worried about is that, like, at some point in time, we're going to need to use Rust to perform, like, calls, right? You're gonna have to communicate with a different machine, and that's gonna involve async. And so I'm very worried that, like, you know, it is notoriously painful and complex because Rust refuses to compromise on memory safety, explicit ownership, and zero cost abstractions. Use Tokio. Okay, so is async in Rust simple if we use Tokio? Hmm. Um, we figured out. We figured out. You hate books. It is bad enough to have it so much. Oh no. Oh no. Okay. I mean, I don't hate books, right? I love books that are like argumentative style or like white papers. But reading is cool. I feel like joy of cryptography. I really enjoyed reading. It's just that like I cannot read fantasy books, like fantasy books or like sci-fi books, because like I prefer maybe like I have no problem with reading. I maybe prefer media that's um that's like a little bit more interactive, like a video or like audio, etc. So I wouldn't say regular books are bad, and like I feel it's just like a matter of taste. I mean, maybe I don't really read fiction or something like that. I do hear that like many people really enjoy. There's like many actually. There's many things I have enjoyed. I think from the small things I read, because usually when it comes to text, I read like small, um, like if it is fiction or something like that, I feel like I read small texts. But the ones I've read have really captivated me. I think one of the ones that have captivated me the most has been uh, The Story of Your Life by Ted Chiang. I really like that. I feel like I like what Ted Chiang produces. It's like short stories, right? Other than that, I usually read like argumentative texts. So, yeah. Um, anyways, let's see. Use Tokio. Tokio is the facto standard async library, I see. Async Rust is fine in terms of design, but for developing practical applications, you can just use Tokio. Okay. No matter which async library you choose, you're going to wish you picked the other one. This is true no matter which one you pick. Okay. Great, Hatter. Welcome to chat. Welcome. Yeah. Hi. Yay. Fancy meeting you here. Oh, you guys know each other from some other place. I have a short life. I just don't care about fantasy books, but they do improve your vocabulary and attention span. Yeah. Async Rust is very similar to C++'s implementation with the exception of more guardrails. For example, you can't directly share object references without declaring an object's lifetime. Interesting. Okay, wait, so help me understand. Async Rust is different from Tokio? Because you guys were saying, like, oh, use Tokio instead of Async Rust. So, like, what do these words mean in the Rust context? So, Tokio is a library for managing async. Do you guys refer to async Rust as in, like, the bare bones of async in Rust? So I'm a little confused, but yeah. Tokio is a third-party library built on top of async Rust. You can think of SCThreads versus Boost library. Okay. But then I have a question, right? Because in the exam, async Rust is a language-level primitive which allows you to do async. Tokio is a library which uses these primitives and provides runtime. I see. Tokio is more than just a library, also a pattern, has opinions about how you're supposed to do async. Yeah, that was gonna be my next question because, like, just like in C++, where you have like std thread, but then you have boost thread, right? Like boost provides an interface that's closely related to what C++ is doing. So is Tokio like very, very sort of close to the Rust model, or is it just different? I think Ray Hatter sort of hinted at the fact that they're a little different. I have a reluctance to use third-party libraries in general. That makes sense. Although, like, I feel like if people are talking so badly about async Rust, we're gonna have to do this. But yeah, I have a reluctance to use third-party libraries in general. Boost, ASIO, or whatever is horrible. No, none of them are close to the bare Rust model. The bare model is extremely painful. I see. But then, does that mean that Tokio sacrifices some things in order to provide the simplicity? Because if yes, then sure, that makes sense. Maybe, it's not ideal, but it sacrifices. And then if it doesn't sacrifice, then why isn't the bare bones Rust model this? Yes, it does, and then not really. Okay, so it seems to be like a disagreement here. So what are some of the things, Grey Hatter, that like you think are sort of left behind with the Tokio, with using Tokio instead of async? You probably write some interfaces for coding if you had network layer file read, right, etc. Tokio brings them too. Okay. Interesting. But that doesn't seem to be a difference, though. Calculate is equally correct. There's no reason you couldn't bail out of Tokio and use the bare model, but this will make Tokio very angry. Okay, I see. Okay, but Tokio seems to be fine, right? So I don't have to worry about the people saying async in Rust is the worst thing we could have ever witnessed. Move out of this language as fast as you can if you're going to do async. Right? Because that matters to me, right? This is going to be a project that's going to be like a few months, for example. And then if then by the middle of it, I'm like, this thing sucks. It's like the worst thing I've ever seen. I don't want to do this. Like, it would be really sad. So I want to prevent that. If using Tokio will not lead us to however people were describing async Rust in the internet, then I think we're good. So much that other libraries assume we have Tokio. That's crazy. Okay. Tokio provides most of the boilerplate you'll need, but then all the code has to be in one of the shapes Tokio expects. Eventually, you want to do something Tokio doesn't support, and that's when you wish you used the other. Async basically works by suspending function mid-execution. Rust uses stackless approach to this, which requires to have language support. It converts function to a state machine, which suspend in places where it needs to. Damn, wait, that's actually pretty interesting. What? Yo. Wait, that's pretty cool. But yeah, okay. So just I feel to make it clear, right? You guys think, you guys in your experience with Rust, those of you that have coded in Rust, will we be okay if we use Tokyo for this project? And like, or will we end up hating it by the middle of it? Maybe there's gonna be some things, as Gray Hater or Hatter said, um, right? Some things that we're gonna say like, oh wait, I wish this was there, um, but like it's gonna be fine. I watched a guy on YouTube who did some introduction to async on embedded Rust, and he explained async pretty well in my opinion, even if he used it for embedded. Okay, so don't listen to me. Okay, Andrew, thank you. I think yes, because I'm sure your code will have networking involved. If you don't know what to pick, you should pick a different language. If you can't pick a different language, you should pick Tokyo. Not because it's the best. Okay, I see, I see. Hmm. Hmm. This is an interesting thing. I mean, I feel like, right, sort of one of the things, the reasons why we started with this project was we wanted to take a look at Rust, right? So I think like it's part of the project to have Rust as a language, but you could also argue, right? You could also argue that, um, like, so I'm very used to C++. I really like C++, so I would more than happily do this project in C++. It's also very convenient because like I also need to prepare myself for like job applications because I'm gonna graduate soon, and like most of the jobs I want that are like related to systems and like system design usually require C++ and ask you very specific questions about C++. Um, so there would be that argument, but I feel like I want to learn Rust, right? I want to learn Rust. I want to sort of break the mold. Not everything has to be C++, and this is our free time, right? So I feel like yeah, it would be nice. In Rust ecosystem, let's see. Don't let making the wrong decision get you stuck. Instead, get better at being willing to throw away code. Okay, this seems like a very good advice from Gary Hatter. I think we can try Rust, and then even if in the middle of it we're like, no, this doesn't work, I'm sorry, but boom, rewrite it in C++ or in Zig or something else, right? But yeah, because I've heard on the other side that Zig has been praised for the way they do async. So that's gonna be interesting when we go to Zig. Um, I think Andrew is gonna be very happy when that happens. In Rust ecosystem, if library is async, it's mostly async for specific runtime, and most of them are for Tokyo. You ever try Zig? Oding next, we'll see. I think it's probably safe to jump into Tokyo, but write your code in a way where you might have to throw away all the Tokyo specific code. Okay. You'll need to get used to using cargo to pull popular code. All C bindings or useful libraries are maintained there. Okay. I'm huge Zig, but I wouldn't say how Zig does async is amazing. Okay, these are just like opinions I've heard of people because I don't know Zig, right? But we're like, oh my god, the Zig async model is so good and it's so perfect and they designed it in such a great way. I was like, damn, you gotta do like a very good job for people to be like async is wonderful. But yeah, um, that's why I also suggest use of CMake and VC package to accelerate development. Hand-rolling implementation teaches you a lot, but you can learn more faster if you don't implement your own hash map every time. That is true. That is true. That is true. Yeah, you're good. I'm sure a lot of people say that. Even I would, if I was previously using Rust, but it's extremely raw. Okay, okay, okay. So decided. We continue with Rust because it seems like Tokyo is right. Um, Tokyo is decent enough for our project, right? Pretty good. Async and Zig isn't painful, but it's extremely raw or low level, similar to Rust. Pretty good. Wait, so then async and Zig isn't painful. Yeah. So then, wait, then Zig make a pretty good decision, right? If it's as low level and raw as Rust, but it's not painful, then that's like pretty good. Although I mean, I feel like it's the fact that like there's a lot of boilerplate in Zig. I see, I see. I feel it's the fact that Rust it's sort of tied to the chains of memory safety, while Zig is maybe not necessarily. Because I don't think Zig implements like a borrow chip or something like that. Please correct me. But yeah. All right. Perfect. Yo. Give me 1 second. I'll be back. Hello. Hello. Let's see. Um. All right. Let's see. What did I say? I also liked Zig when I tried it. Yo, let's go. More than Rust for sure. The thing that makes Rust painful is its memory model. Yeah, if you know how to manage your own memory, all that pain goes away. And it's replaced with SegV if you were wrong about being able to manage your own memory. Yeah, I hear this all the time. Everyone who gets used to Rust and then tries Zig, so many end up saying, this is all I really wanted. Oh, interesting. Okay, wait, so we're doing the right progression. We're doing like first Rust and then seeing if we, memory model and everything, and then we transition to Zig, which makes the experience more pleasant. Pretty good. It feels like just a better C, nothing fancy. It compiles fast enough, really enjoyed it, but it is low level. For reading a string from stdin, you have to manually manage memory, the stream itself, etc. Do you know a language with minimal memory usage during compilation, especially during linking phase? Tamal, welcome, welcome to the stream for the first time. First time chatter. Okay. Yay! Okay. Let's see. Don't change this line, yes for sure. Exercise, interesting. Okay, so what are we gonna do now? It's a great question. I think it's 7 p.m. where I am at. We started streaming at when? Like 2 p.m? 3 p.m? So I think it's a natural point maybe to end the stream. Although I do want to Okay, let's try and finish Rustlinks. Once we finish Rustlinks, we start with the actual thing. And Joy of Cryptography is now going to be replaced by reading the original Bitcoin white paper, which I'm very excited about. I feel like I'm very excited about reading like the original white paper instead of Joy of Cryptography. Like, it is Joy of Cryptography gave us all of the knowledge so that now we can be like, oh, that makes so much sense. But yeah. We'll take a look at that white paper, and we'll probably take a look at other white papers from other sort of cryptocurrencies too, other blockchains to see how things can go. And yeah, yo, wow, when did VS Code change this much? What do you mean? Wait, VS Code? Okay, so one thing is like VS Code for some reason has like a little square, has like a square around stuff. It like I didn't like the change. I updated it and then like all of a sudden all the interfaces I loved were gone. And now it's like little squares. I kinda don't like that, but it is what it is. So yeah. It's okay. Um I'm using Go for a project, but I understand it doesn't fit all use cases unless you are ready to do a lot of manually and go against the design. IRC, resident shared size, the actual hardware memory use. Okay. Perfect. Alright, guys. I think this is a natural point in the stream. Actually, now that I remember, please don't let me forget. We need to rate people. Like, let's try and rate someone. So who can we software? Okay. Let's see. Who could we rate? So there's a lot of people online right now. Is there somebody maybe doing Rust? Maybe somebody doing C++? Something that you guys may be sort of interested in? Preferably not with AI. Like, not that I hate people that use AI, but like I like it when it's just like, um, I like it when it's just somebody coding and they're like understanding and enjoying everything. Do I have this sorted by views? No. Recommended for you. Let's see. Maybe it picks up that I like C++ and try to use RSS only because things like Chrome say they take 100 gigabytes, but really only use like 10 to 20. I see. Game dev. Can I make a game without an engine? What? What does this even mean? What does this mean? Okay. It's using just call it. Okay, I see. That was a funny title. I was like, damn. I don't see any other streams we can raid that are like maybe our type, right? 43% of games on Steam by number of like games with custom engines. Really? Damn. But like this one would be like, can I make a game without an engine, right? Like it's like the maybe like some people create their custom engine, but that's still an engine, right? My pride is okay. Trying to break signal space time. Let me know, guys, if you find someone we can raid. If not, then I think we can leave it at that. Oh, there's us. Yo, live custom engine development, prototyping a new idea, Minecraft Donut SMP based rating. What? Okay. Face Tuesday. Hmm. What? What is that thumbnail? Oh, no, I have to go through the ads. Sorry. You might want to look into adding a swap file you can mount. That'll make things slower, but it won't crash. You can also tweak the OLM killer to be a bit smarter if you really want. But that's what chat is for. We do coding challenges, little web dev projects, and a fair amount of chat as well. Come hang out with us. Yo! Oh, it hasn't started yet. So we don't really know. We don't really know what this is about. Okay, that's fine. I'm so sorry, guys. It seems like nobody is like coding something that we may be interested in or that is not AI related. Cheers, Killy. Hope you have a good day or night. Yo, anyway, I gotta go. Oh, bye, Killy. Bye bye. Yay. Alright. It's 1 a.m. here. Damn. Also try to limit number of threads. There's a compilation. Yeah, I think. C++. What is this person doing? Oh, they just have music. It seems like they don't interact with the people that are there. Oh, I see. Yeah, it's okay. I don't see a dev that maybe we can raid. Maybe next time. Maybe next time. But yeah, all right. All right, guys. I think it's time to end the stream this time because it's already 7 p.m. for me basically. He was writing the Doom engine. Oh wait, this guy, the one that had only music. Ubunix. Maybe. You can declare only what you need. Good night, Sharif. Yay! Good night, Big Eco One. That's how you make your binary small. Thank you all. iColonQ is a cool guy. Okay, wait. iColonQ. Because you know, if we have the possibility to raid people, then we can just do that, right? lcolonq. Making an... What? It's a VTuber in a terminal. This is insane. What the hell? Why is this person having 215 beats per minute? Oh my god. Bro, they're about to die. Bro, what? Making a nicer GDB interface. Wait, this could be a... Yeah, let's rate this one. I mean, it has almost 200 people. So we're not gonna make much of a dent. But it's okay. If you guys are interested in this one, let's rate it. So let's do /raid lcolonq. So I think this is the command we use, right? Emacs is good. Alright, let me know, is this a command you use? Raid :q. Raid lcolonq. Let's see. Alright guys, if this works, bye bye. Yo, perfect. Bye bye. See you everyone. Yay. It worked. First raid.